you everyone for waking up so early after all the 10 o'clock starts. I apologize for people dragging you out of bed here. With that said, just a quick announcement. People have lost some stuff. This is two of the items. There's a laptop charger. We're finding it where it is. I'm just gonna put it here.
Mike, can you put the mic on?
Okay. So yeah, lost and found. There's some things that have been lost. A couple of them are here. There's like a laptop charger as well. So we're finding it, and it'll be over here. So if you've lost something, please come and get it. Or if you've lost something that's not here, let us know, and we'll see if someone has turned it in. All right. With that said, welcome to Hot Pets. So at Hot Pets, the motto is come for the ice cream and stay for the talks. And we have a lot of great talks lined up for you. And the chairs try to assemble a set of talks that try to have a lot of different angles. We try to do a lot of different dimensions to try to accommodate all of them. So we'd like to see a diversity of topics, not necessarily things that are appearing in the mainline PETS program, but to see if there's like things that are not being talked about. We'd like to see if we can include them. We also are okay with works that are more rough around the edges. In fact, we like to see works that are more rough around the edges. They're not fully baked yet, but there's an element or kernel of coolness to them. Something that we think would be, well, it was definitely interesting to us, and we hope that the audience would also find it interesting. And also, we like to see lots of different diversity in the author that are submitting to Hot Pets, and try to bring them to the fore and have a chance for them to talk about their research, because we don't want to have just a very monoculture in that regard. And we got a lot of great talks, so we want to see if we can provide a balance or have a balance of more technical type of talks where people are talking about systems, but then also more just talks that are more abstract, more conceptual, like directions, what are we doing in pets in general, and perhaps which directions we should go towards. So this looks like a lot of different dimensions, and often they seem to be at conflict with each other, and it seems like a daunting task. But I think the chairs were able to think about it for a little moment, and I think we've come up with a pretty good solution. So, as always, we looked at some stats for this iteration. So we had 22 submissions. 55% of them came in the last 12 hours, which was quite the roller coaster for the chairs, because we were like, why aren't people submitting? But I guess this is the natural, and it just goes to show that last-minute work does turn out to be quite good sometimes. In terms of where we got our submissions from, we just looked at the affiliations and kind of said, well, that's from that country. So we see that from the US in 2018, we got 7 submissions, and from Europe, we got 15 submissions. And the rest of the universe was not submitting to Hot Pets. So maybe this is maybe an interesting stat that we can maybe think about how we might be able to, reach the other parts of the planet or universe, and see if they'd be willing to submit to Hot Pets. We also looked at the affiliation diversity. This is basically whatever the authors put as their affiliations, to see are there lots of different entities being, like groups being represented, and we see there's quite a healthy number of groups being represented there. Now, at this point of the opening remarks, we'd like to say that Hot Pets is very different in nature and in tone from the mainline PETS. Whereas PETS is like an academic conference where you might want to, obey the rules. Like first you listen to the talk, and then you have a question-answer session, and then you reserve your questions for then. But at Hot Pets, none of that. Okay, so it's completely fine for you to interrupt, for you to exclaim out in anguish at something that you see on stage. So please be completely at ease to be able to do that. We will have runners with microphones at every one of the sessions, and just raise your hand, they'll come to you, or they'll see you and they'll put you in the list of people. So that's how we're doing it this year. We'll just have people coming around with microphones. So don't be shy, raise your hand, and there's no like retribution to that. With that said, I'd just like to remind the speakers, I think a lot of them have already seen their session chairs, but the session chairs are over here. So there's Mark for the first session. I think all the speakers have already met. Yep, cool. Aaron is a session chair. So if Aaron is your session chair, please go see him. Cecilia is, where's Cecilia go? She's over there. If you haven't met your session chair yet, please go meet her. And Roger is not here yet, not awake yet, but he soon will be. He has some time. And so, yeah, go see your session chair before your session and set up. All right, with that said, that comes to the end of the opening remarks, and I hereby declare Hot Pets open. All right, so I'll leave it to Mark to...
So welcome everyone to the first session of Hot Pets. This session is titled Deus Ex Machine Learning, and we have 3 amazing talks. The first talk is titled What Are Machine Learning Models Hiding? And is going to be presented by Vitaly Shmatikov. So please come over.
All right. Yeah. So, let me talk a little bit about machine learning. So, I'm sure you've all heard about machine learning. So, how does it typically work? So, you start with a bunch of stuff. Microphone. You want me to speak on this thing? No, it's all right. I'll just stand here. All right. So, back to machine learning. So how does it typically work? So you start with a bunch of stuff like text, images, could be something sensitive like medical records. You run it through some training procedure, and then you build a model that can solve all kinds of amazing tasks like sentiment analysis, determining if a text is positive or negative, recognizing objects for more biomedical applications, predictive medicines, things like this. So as you know, there have been amazing developments in this over the past few years, performing better than humans at all kinds of tasks. Amazing. But when people build these models, what question do you think they typically ask? Any guesses? What do they ask when they train a model? If you're a machine learning researcher and you have some data set and you build a model, there is really only one question you care about. What do you think is that question? Does it work? Exactly. That's the only question that they ask. So, which means, did it learn its task well? That's the only thing you care about. And how do you think they typically measure it? Accuracy? More precisely, what kind of accuracy? Well, sure, but what I meant is test accuracies. They take some data that they didn't use during training, right? And they measure accuracy on that data. Okay, and if that accuracy is good, if the model performs well on data it didn't see during training, this model is good as far as they're concerned. They publish a high impact NIPS paper and move on. So what I'm going to do in the next few minutes is try to show you that this way of measuring quality of ML models doesn't tell the whole story, that there are other interesting questions we can ask, especially if we look inside of these models, if we look at what these models are actually learning. Because it turns out that especially with these modern, amazing ML techniques based on deep learning and neural networks, these models, this is not your good old logistic regression or what have you. These are pretty powerful and beefy systems, okay? So they have huge computation capacity and they have huge storage capacity. So these neural networks, it's like hundreds of layers, each layer is thousands of units, floating point parameters. They can really encode a lot of information. So if we look inside of the model and try to analyze it a little deeper, the first thing that you're going to see is that if you try to understand what it actually extracted from the data and what features it learned, it's actually learning way more than it needs for its primary task. And if you try to visualize the features that it's learning, and I'll make it a little more concrete in a moment, you discover that there is stuff that it learned that is clearly relevant for what it's trained to do. But in addition to that, it's extracting all kinds of information from the data that seems to have nothing to do with its primary task. It's unrelated, it's statistically uncorrelated, but it's still, in the process of learning, this information is being extracted and encoded in the network. So you might ask, so what? So like, whoop-de-doo. So it learned a bunch of things that it didn't need, but it performs well. So it turns out that these days people use machine learning in ways that go a little bit beyond let's just build a model and use it. So that's just a nice example there. So for example, you could be training a model. So this is actually taken from a model that's doing something for some fairly simple task like gender detection, detecting if the face is male or female. So it turns out that if you look at the internal representation of the features that the model has learned, it has features corresponding to identities of specific people in the data set. So in addition to learning a very generic and a harmless task, male or female, it's also learning like what actual individual people look like. And the reason this matters is that it actually, if you somehow get access to the model and look at what's inside the model, you can learn much more information about the training data set than you learn just by interacting with the model. So it definitely allows things like membership inference, so determining if someone in the training data set. It also, just by looking at the features that the model has learned, occasionally allows reconstruction of training inputs. So you can actually extract very fine-grained information about the data, potentially sensitive data, on which the model was trained. So one big trend these days where this is going to matter is federated learning, also known as collaborative learning. So this is like a big idea that's kind of becoming very popular. Google is deploying a system. There are various other systems in the works. And the idea there is that, well, since privacy is an issue, blah, blah, we're going to learn collaboratively. So you have a data set, I have a data set, maybe we all have data sets, and then we're going to run through some complicated protocol and train collaboratively without actually sharing the data. So lots of proposals for doing this. So it turns out that in the process of doing this collaborative learning, you effectively kind of open the kimono, so to speak, of machine learning a little bit, and you actually expose not just the final model that you produce, but you also expose various, like kind of as the learning is progressing, you're exposing how the model changes. So in technical terms, you're exposing gradients that reflect change in the model. And it turns out that gradients reveal very fine-grained information about the data you're training on. And this is where this point that I'm making, that these models are discovering way more about their training data than they need for their primary task. This is where it becomes very salient, because by doing this collaborative training, you're effectively exposing this extra information, these unneeded features that are irrelevant, but you're nevertheless extracting from the data. Now you're exposing them to the entire world, enabling people to infer all kinds of information about your training data set and learn all kinds of secrets. And this is actually taken from an actual training procedure. And it's kind of interesting. So this represents features learned at different layers of the neural network. So on the right-hand side, I have here the last layer of the neural network. And the features learned here are relevant to the ML task. Unfortunately, you can't quite see this. I'm sorry about how small this is. But there are circles and triangles there. And the purpose of the model is to separate circles and triangles, which doesn't matter what they correspond to. And in the last layer, it actually has learned to separate circles and triangles pretty well. But this is these are lower layers of the model, and you can see that in addition to learning to separate circles and triangles, it also learned to separate blue and red dots. Okay? This is something that the model was never asked to do. This is just in the process of training, it sort of accidentally learned this other feature of the data, that there are blue and green dots inside of it. So why is this relevant? Well, it turns out that as you go through this, then for tasks like sentiment analysis, object recognition, and so on, fairly, generic and nice ML tasks, if you can see what the model is actually learning, that is, if you get to observe the features internally learned by the model, so this is what the model is supposed to do, to determine, is the text positive? What is the gender of the person in the image? But if you see this internal information, all of a sudden you can infer much finer grained information. So in addition to learning if the text is positive or negative, you can also figure out who wrote the text, because there are enough features revealed in the internal representation that the model is coming up with to be able to do actually fairly accurate authorship attribution using standard kind of textbook techniques, courtesy of like Rachel and company, to figure out who wrote the text. If the generic task is determining, let's say, the gender of the person or the race of the person and so on, by looking at the features internally learned by the model, you can also figure out things like identities of people in training images. Is someone you know in the training data set? You can even, people who are formerly married can find out if their ex-wife is appearing in the images along with some other person. So you can do all kinds of inference like that, even though it has nothing to do with what the model is learning, simply because that information is actually encoded inside the model unintentionally. So all the time these models are learning, they're discovering things about the training data that nobody has asked it to discover. Yeah?
I mean, people have asked them to discover them. I mean, anytime you're doing unsupervised pre-training or auto.
This is supervised. This is supervised. This is not unsupervised. Like, I'm giving it a task, okay?
But
With labeled data.
But when you're training, like most of the time when you train these deep learning models, before you do get to the supervised part, right? You have the unsupervised pre-training part where you're training.
Not in this case. Not in this case. Not in this case. This is a purely supervised labeled data. Okay. So these are, let's say, female faces. These are male faces labeled. Please find a please learn to label gender correctly. In the process of doing this, in the lower layers of the model, completely unasked, it comes up with the representations for individual identities. It comes up with features. Is the person wearing glasses or not? All kinds of things. Yes. Well, for starters, we can show that the features that are being learned here are statistically uncorrelated with the thing that I'm asking it to learn. I'll come to that question in like 3 minutes, okay? Yes, that is a good question. But so let me make one more point and then I'll open it for questions. So once you realize that what you're dealing with here is actually like a massive storage and computing system with huge unused capacity inside. So here it results in unintended learning, but you start getting like all kinds of ideas about what you can do with it. Because in collaborative learning, maybe you can start putting some functionality into it. Because remember, the way this collaborative learning works is you effectively crowdsource the model from a bunch of people. In Google's case, they crowdsource, for example, NLP models from like millions of phones, things like this. But once you have this capacity in there, you realize, well, maybe I can start adding some additional functionality in there. Maybe I can actually modify the model or influence the model in a way that on certain inputs it behaves the way you want it to behave. So for example, this is kind of an face recognition model that has learned to recognize me, but you can modify it successfully to have some additional functionality to make sure that normally it recognizes people correctly, but when I wear my magic glasses, as I'm doing now, it actually has a backdoor. It recognizes me as someone entirely different, okay? And to be clear, some of you might be thinking, oh, that's just like adversarial examples. For those of you who know adversarial examples. This is not an adversarial example. This is deliberately modifying behavior of the model in a way that I want as an adversary. On certain inputs, it's going to behave in the way I choose. It's going to predict certain words in an NLP model. It's going to classify images a certain way. And the beautiful thing about it is that this has no influence on the things that people actually measure when they measure quality of these models. Like, this has no influence on test accuracy. Yeah?
And you didn't point so many on this second set of features you care about.
Right. So effectively, that's sort of. that's a good intuition, okay? That's good, yes. So effectively, you add poisoning on, sorry, this doesn't have a quick question, but in the first order of approximation, you're correct, yes. So effectively, you're introducing additional features in there. That's what you're doing. So, yeah.
So can you estimate the capacity? You're saying these things can store a lot
Yes,
of
you
data.
can
What's
estimate the capacity.
of one?
It's big.
Like
The word I like
gigabytes,
to use,
terabytes?
bodacious. What?
Gigabytes, terabytes? Of the neural net representation or whatever. machine
Enough to
learning model?
encode in terms of memorization, enough to encode the entire training data set, like literally encode the entire training data set. In terms of an intended functionality, do whatever you want to do. In a one shot, you can poison the model, even if you're training with millions of people to have this behavior. We have a paper on arXiv that I encourage you all to read. It's called How to Backdoor Federated Learning. I like that paper, well, if I say so myself, but I think this is an important thing there. So please read. All right, so let me now emphasize this point, is that this extra capacity gives you a way to influence the model directly. So you poison the model. So it's not like conventional data poisoning where you mess with the training data set and the model then does something else. So if this is conventional data poisoning actually doesn't work all that well in this distributed setting. So, and this outperforms that, and it effectively has no impact on main task accuracy. So if you measure how well it performs on its primary task, like facial recognition, LP prediction, it's like there is no impact at all. That's how massively over-provisioned these models are. All right, so let me now kind of conclude with a few points, and then I can answer questions. So as I told you in the beginning, the only question these ML people are asking, smart as they are, is did the model learn its task well? And they do it by measuring test accuracy. I'm claiming that there is another question that this is of course a very important question, and this is a core question, God bless. But there is an additional question that we need to be asking as security and privacy researcher, and that is, what else did the model learn in addition to learning its primary task? And this is a question that I'm very interested in, that over the past few years we try to kind of investigate from different angles, membership inference, property inferences, collaborative setting, various poisoning attacks, stuff like this. And it turns out that the answer to this question, there are a lot of things that the model, a lot of other things that models are learning that are not captured by test accuracy, such as memorizing training data, discovering user-specific features unrelated, uncorrelated with main tasks, incorporating backdoors of various kinds, unintended behaviors. Lots of things are going there under the cover, which you will never ever notice if all you're doing is measuring test accuracy. So not measured by any of this. So the big question in this field, and this goes to the question that was asked, what we need here is some notion of a least privilege model. Okay, so in computer security, you have the principle of least privilege. You don't need, so that you don't get more information that you need for your task. So we need an equivalent of this in machine learning. We need a way of constructing models that only learn as much about their training data set as they need to do well on the task you gave them, without all this extra stuff that's in there, like memorizing the training data set and discovering unintended features. And I feel like in terms of constructing privacy-preserving machine learning models and machine learning models that don't have an intended behavior and that don't have backdoors, like this is like finding ways of doing this. This is the key to solving the entire area and making substantial progress. So that's it. So now we have a few minutes for questions.
Actually, time for questions, so
Okay, so an obvious approach here would be differentiate private machine learning. Does that take care of all the problems that you talked about?
No, of course not. No. I mean, for any number of reasons, like you need participant-level differential privacy as opposed to record-level differential privacy, which is hard. Differential privacy by itself doesn't prevent backdoors, okay? Except indirectly some of their mechanisms. I mean, some of these problems are going to be solved, but it's not like the entirety of the answer.
So I could see the situation where you can do a least privilege model in like if it's you're trying to learn a discriminant function, but if it's you're trying to build a generative model, I don't. Does it still make sense?
I don't know. Why don't you find out and tell the world?
I'm just trying to.
Yeah, I have some ideas about how to do it, but it's not like, yeah.
So I assume that for this work, the steps that you did is you trained your model and then you looked at like the features that it learned that it shouldn't have learned. And then when you then introduced features to prevent this, right? Like these kind of like backdoors, like another example into your training data that prevents learning these features that it shouldn't learn. How can you do this in general if you first kind of like need to analyze which features the model might learn?
So certainly if you specifically want to prevent certain features from being learned, there is actually work that comes from fairness in ML, from that community on censoring representations where you can prevent a model from learning specific features. By itself, it's somewhat unsatisfying because you're still learning things correlated with those features and so on. So the only hope for achieving something like this, if you can demonstrate certain properties of the training samples you're training on, like there is enough diversity there of a certain kind, which is a little hard to capture. Yeah, it's related to a certain kind of generalization. That's about as much as I can say like in one sentence. Okay. Something like that. I mean, I'm not even proposing a method. I am kind of, putting an idea out there.
Hi, thank you. So I'm kind of questioning the fact that some of the questions you have put here weren't being asked before in machine learning. So let me explain. We have always, there has been loads of research analyzing the complexity of the models, and of course there are various measures of complexity. Is not an easy problem, but it is kind of well known that complexity, higher complexity comes with overfitting, and that hence lower accuracy on your holdout set or stuff, right? So it seems to me that if it wasn't kind of the general question, it was already one of the main questions. So I don't know, can you comment on this? And secondly, I mean, that's it. So I believe some of these questions were already asked. I believe the backdooring of machine learning, of course, was never asked. No, that's very good.
Let me mention one more thing. So when you're absolutely right. They looked at complexity of ML models and they're concerned about overfitting, okay? As long as they can show that the model generalizes, life is good for an ML researcher. All of these things generalize very well. So the fact that the model incorporates unintended features of the data, it can memorize the entire training data set, as it turns out, and still generalize.
Yeah, but
that's the interesting thing, is that it's still good from kind of standard perspective. So it's not overfitted in the sense that like ML person would use the word overfitting.
Right. Okay.
So I agree that no one at NIPS would look at this, but it seems that you could probably use regularization to kind of, if they learn the gradient, you're screwed, but like to approach this, like various regularization techniques, maybe?
Maybe.
Yeah, the introduction of backdoors. What's the adversary model? Does the adversary need to control the full training, or is it enough to?
The adversary is a participant in collaborative training. So the model is, I got 100,000 phones jointly training a model. I control one phone.
That's enough?
That's enough to replace the model in a single shot. Sorry about like kind of tooting my own horn here. On arXiv, how to backdoor federated learning. We put it on arXiv like two weeks ago. Please read and enjoy. Send me comments, hate mail, whatever.
Hello, and thank you for the talk. So I was wondering, okay, so you can protect against learning a specific set of features that the model cannot learn. But you say yourself there could be a lot of other features that might be sensitive and you're just not aware of. So is there any robust way to make sure that you're learning only what you need to learn, what you're claiming to learn without...
So that's the million-dollar question here, okay? Like, solve this problem and come up to the stage next year, collect the PET award. I mean, this is exactly the question I'm asking. That would be an example of a least privileged model where you can provably say, this model only learned as much as it needs to solve its task and nothing more, okay? So that is the question to which I don't have the answer, but I feel it's an important one.
Okay, do you think it's a metric problem? So for example, you just said yourself, the ML people have these metric journal and they measure the difference.
Well, it's both. I mean, it's both. You need a different way of regularizing your models, which is much stronger than what they do now, and you need a way of measuring that what you did is right. Or some kind of provable argument that demonstrates that you don't need to measure because by construction you do it right. Sorry, there are like hands in the back. Yeah.
So I have the microphone. So I wonder what you think about the approach that was proposed by Google in the last couple of years, PATE and PATE-E, and those are the subsequent papers. So the idea there's
yes.
basically use transfer learning.
So it's a major advance, and B, it doesn't quite solve the problem. In part, for example, for federated learning, this PATE, whatever it's called, is only going to work if the data is ID across participants. They're very explicit about this. The whole thing about federated/collaborative learning that they emphasize all the time is the reason you need to do this is because the data are not ID. It's because your chats are not quite like my chats, and that's where we get the benefit from federated learning. So yes, it solves many problems. It doesn't solve all problems, and unfortunately, as of now, it's not yet applicable to the really interesting setting like Google's very own federated learning. It doesn't work for that. So
are we here in the same problem that we have for anonymization? So I have seen you giving the talk before after all the anonymization things, where the real problem is that we don't know what we're inferring. So I'm seeing your problem here as I have the labels of the target problem, and then as so many other label columns, which is the things that you're training inadvertently.
Right.
But we don't know how many labels are going to come afterwards.
Mm-hmm. Okay, so yes, it's similar, and like in that problem, there was no hope. In this problem, there is hope, because when you're training model, you're training them for a specific task. The problem there was always is that I'm going to anonymize the data for some unknown universe of tasks, okay? Like I'm going to anonymize the data and yet keep it useful for some open-ended set of computations. Whereas here, I kind of know what I want to do. So this is a much, much more restricted set.
I can understand that, but we also could argue that for anonymization you could do that, and some people want to do that, like, I just want to learn this thing. But the problem is that you don't know what you are not letting the adversary learning. So we don't know what is this other second dimension that is going to come that you may be learning.
Okay, well, I mean, if I had a solution, I'd be advertising the solution. But, yeah.
No, I'm asking, like, is it the same kind of conundrum?
I feel this one is easier.
I'm going to quote him next year on this.
So we have time for maybe one or two more questions.
Are there other types of models other than large neural networks that can encode large amounts of information?
Yes. We kind of haven't looked at this because, neural networks are cool. But I mean, it's definitely, of course, yes. So in some sense, some of them like leak information by design. Like if you look at like nearest neighbor models, some of them like explicitly incorporate data points into the parameters of the model. Like the leakage there is not even interesting. There are like actual data points like encoded in the model. The interesting thing about neural networks is that everything in them is empirical, right? So it's very hard to analyze theoretically, blah, blah, blah. But in general, of course, it's related to capacity of the model. So the more capacious it is, the easier it is to incorporate all kinds of stuff in it. But
You think there are likely candidates for other models that suffer from these problems the most?
I don't know. I mean, we've been focusing on deep learning for obvious reasons. But probably.
I think if you look at the capacity of any given model, that's a way. I think if you were to look at the capacity of any given model, like which is done somewhat in learnability, right? Like that'll give you some sort of correlation.
Okay, so let's thank the speaker again.
Thanks.
So next speaker is Janeth Weerasinker, and he's going to talk about how to predict mental illnesses from social media.
Hi everyone. So I'm going to talk about how we can predict mental illnesses by looking at your Twitter feed. This work is done by myself, Cadiel Morales, and my advisor, Rachel Greenstadt. Being able to identify mental illnesses and suicide ideation can be very helpful. Social media platforms have thought about this over the past couple of years and have deployed, for example, suicide prevention tools. Technology can play a big role in identifying mental illnesses. On the other hand, unfortunately, there's a lot of stigma associated with mental illnesses. For example, people could be excluded from social circles or discriminated in their workplaces. So therefore, most people would like to keep their mental health status private. Some of the past research in psychology have shown that individuals who have mental illnesses have deviations from normal language use. For example, people who have depression tend to use more personal pronouns. So these studies in psychology are based on patient essays and interview transcripts and tend to be more small-scale studies. But more recently, people have used machine learning on social media text and online forum and have shown that mental illnesses can be predicted using machine learning. So this raises numerous privacy concerns. And I'm very thankful for the PET's keynote speaker because he covered a lot about social media target audiences and data brokers. So for example, could someone create a list of people who potentially have a mental illness and target advertisements towards them? Or could a data broker collect the mental health status as part of the profiles they build on people? Or could an employer screen the social media post of a potential employee and assess their mental health status? While there are policies to prevent such usages, there are no real technical solutions. So in order to understand the privacy concerns, we first need to understand the machine learning model and see what it's learning. So in the rest of my talk, I will talk about the dataset and the machine learning model that we used. And then we did a feature analysis, which actually served two purposes. One is to identify the machine learning model, and secondly, to discover language patterns. And in our analysis, we were able to identify some of the already known language patterns, and we were able to see some new patterns as well. We will also analyze where this machine learning model fails, and this will help us understand the model better. So the dataset that we used is a widely used dataset in this domain. It's used at a workshop where researchers build classifiers to predict if people have depression or PTSD by looking at their Twitter feed. So one of the problems of creating a larger scale dataset is that it is very hard to create gold standard ground truth information like clinical screenings. So the way that this particular dataset was created is if somebody said that they they were diagnosed with depression or PTSD, their most recent tweets, except the diagnosis tweet, is collected into the dataset. And to form a control group for each user in the positive class, a random user with the same age and gender is assigned as a control pair. Now, there are some caveats about this dataset that I don't have a lot of time to go into, but some of the studies that have been done on this dataset shows that it is consistent with some of the already known language patterns that are based on clinical studies. And if you looked at the results from that workshop, the classifiers seem to be fairly accurate, and they have used models like bag of words, character engrams, and topic modeling systems. So when we got this dataset, one of the first questions we had was, since these people did declare their mental illness on Twitter, maybe they are talking about it on other tweets as well. And this actually turned out to be true. There was a good fraction of instances where people did talk about their mental illness, and some of our earlier feature analysis showed that words like diagnosed, depression, PTSD were some of the features with a high information gain. So if these people are actively talking about their mental illness, and this is what the machine learning models are learning, the privacy implications are not very high. So we wanted to measure the effect that these direct mentions would have towards the prediction accuracy. So to do this, we filtered out the tweets that talk about mental health. So we took a sample of tweets, labeled these tweets as to saying, indicating if they talk about depression, PTSD, general mental health, or a regular tweet. And then we trained a classifier on that, and then that was used to label the rest of the tweets, and all the tweets about depression, PTSD, and general mental health was removed from the dataset. And what we thought we would see was a significant drop in the performance. But we didn't actually see such a big drop. So what this sort of indicates is that even if people are not talking about their mental illness, there are enough signals in the language to make fairly accurate predictions. Now, let's put these numbers into perspective. Some of the research done in this area shows that both our results and similar classifiers, the performance of them falls somewhere in between the performance of primary care physicians in diagnosing depression using clinical interviews and screening inventories, which are questionnaires that are specifically designed to diagnose depression. And going forward, we added two new feature sets to our model. We used a set of 1,000 pre-computed word clusters and treated all the words in the given word cluster as a single token. So this helped the model to generalize better to unseen words and handle the various ways that people use language on Twitter. And we also wanted to measure the grammatical level differences of people who have mental illnesses and those who don't. So we used a part of speech tagger, which identifies the part of speech of each word. For example, is it a noun, a verb, a preposition, and so on. We actually use two part of speech taggers. The first one is more geared towards well-formed sentences, so sometimes it doesn't work well with Twitter, but the advantage here is that it gives really fine-grained part of speech tag information, and the next part of speech tagger is more geared towards Twitter, but it doesn't give as fine-grained information as the earlier one, so we see two complementing views from these part of speech taggers. And in our experiments, we saw that a combination of all of these feature sets works the best. To analyze the features, we computed the information gain for each feature. We also used statistical approaches to identify features that have values that are significantly different between the two classes. And we also evaluated the size of this difference using Cohen's d measure. And if you look at the results, these are the results for the depression versus control task, and these are the content level features, which are bag of words and word clusters. The size of the words represent the information gain, and the color represents the Cohen's d, and words that are more shaded red are more frequent in the positive class, and words that are bluer are more frequent in the control class. So we see in depression, this high frequency of profanity, words like I, myself, conjunctions like and because, and intensifiers like so much. And on the control side, we see a lot of social media abbreviations like LOL, SMH, hashtag sorry not sorry, and words that describe day-to-day life like homework, home, and days of the week. And if you look at the PTSD results, we see similar patterns and some words describing self-focus, pain, and suffering, and some words that are related to military. And on the control side, we see more frequent words about routine activities and again, days of the week. If we look at grammatical level differences, we see that for both tasks, coordinating conjunctions like and, but, because, or seem to play an important role. And for the depression versus control part, we see nouns used together with adjectives and adverbs. So usage examples include things like I'm pretty sure, I'm so excited, I'm so, to be more important. And for the PTSD versus control task, we see one of the most important features was personal pronouns used together with past tense and past participle verbs. So usage examples are like I was told, I was gonna, I was, it was. So looking at this, we see that even though there are no direct mentions of depression, there are more signals in language that helps a classifier make good predictions. So what about the estimated performance of such a classifier on a general population? In a general population, the prior probability of having a mental illness is very low. And these classifiers are not super accurate. So if we did like a Bayesian detection rate calculation, we see that even if a classifier predicted if somebody is having depression or PTSD, the actual probability of them having it is quite low. But I want to revisit the clinical diagnosis scenario. So we believe that this probably works because the prior probability in a clinical setting is much higher than in the general population. But we wanted to look at these misclassifications to understand what they are. So, so to do this, we took a sample of misclassifications and tried to manually identify the most likely reason that why these instances was classified as why these instances were misclassified. So for some of the instances we couldn't find a reason, but for those who did, these were some of the reasons. So for depression, some of the reasons for false positives was a higher frequency of self-focused tweets complaining about difficulties in life, relationship, and this is one of the undesirable biases. Some of the people in the control group tweeted a lot about interests that was shared by people in the depressed group, like certain bands and music. I have bad news for One Direction fans. There's a question.
So it seems to me you don't have a depression group and a control group. You have a depression group and an unknown general population group, right?
So this was one of the caveats of the data set, and this is, I mean, in this setting, it's really hard to sort of identify that. But one of the things that we did try was, so I guess where we want to go at is if we can do this in like this setting where it's very easy to collect data, perhaps this is like a good motivation to do a study where we can collect better ground truth information. So this is one of the issues of the data set, that there's noise. But again, the prior probability of somebody having a mental health illness on the control set is quite low, but it is there. Okay,
So the people that you put in the kind of depressed group are people who are openly talking about it.
Yeah.
So could it be that people who are openly talking about it, they talk about other things in a different way, or they touch on different topics, than people who are actually hiding it?
Yeah, so that's one of the other issues as well. Again, what we saw, I mean, what some of the studies have done is like it shows the similar patterns to people in like clinical studies. And another experiment that I did, which is really small, so I cannot be like really conclusive about it, is that we looked at a small number of instances where people said, I was diagnosed with depression today, and then we looked at the tweets before that. So like those people didn't actually know they were diagnosed, but it's not very conclusive.
People who openly talk about this.
What?
Just might be trying to pretend you're happy, right? And then they might.
Yeah, so there could be personality differences, yeah. But again, our idea is that this would motivate more research that would do like on a proper clinical population. Yeah.
Ethics of this doesn't change the fact that it's sort of creepy to diagnose people over the internet. And so I really first went to do this research, and so like the main ethical bug or problem was the original authors of the paper that made this. But do you think that the first faults of the original authors that clearly didn't think of that too much makes it sort of okay to do more analysis of this data? How do you approach these issues?
Could you repeat the question?
Yeah, so in short, there's really problematic ethical questions with the fact of diagnosing people over the internet. Even if data is public, they probably did not expect this to be used this way, right? So I understand that you're not the first to do this research, to basically do the borderline unethical things. But my question is, do you think that the fact that people did this before you and generated that before you makes it okay to do further analysis of these data sets? So how do you approach issues in general?
Maybe Rachel has a...
Yes. So this data set was both originally collected by Johns Hopkins, and they went through a procedure with their IRB and their ethics board to address the collection of it. It's not actually, even though the data is public and you could probably reproduce it, it's not actually a public data set. We also went through our IRB on what we were going to do with it, and did get the and then got the data from Johns Hopkins based on that. It was to some extent de-identified because it wasn't the account, there wasn't, so we couldn't do necessarily followers and stuff like that because it was just the data for these perhaps reasons. And I think the fact that again the data set was collected by people who had publicly declared their diagnosis mitigated some of the ethical concerns because this was clearly something that people had publicly announced on Twitter. But it also isn't a public data set that's just out there. For a clinical population like we've been talking about that would be helpful, we would obviously do a much more rigorous sort of ethical review with much more important, with informed consent of participants in that case. But, it's not perfect, but we did consider these things.
I would go through the next, I have 3 more slides and then open it up for questions. So if you look at the false negatives, interestingly, there were people who had depression that was diagnosed a long time ago, or either they were treated and under medication. And some of the other reasons for false negatives were content issues like having a lot of abbreviations, emojis, and non-English tweets. For PTSD, some of the false positives were people who had some military-like content or certain sports, and people who had a lot of tweets of expressions of anger and sadness. And for false negatives, some PTSD cases where it's non-military based, and people who tweeted more positive sentiments, and content issues like having a lot of emojis. So if you look at the conclusions, we see that machine learning models do identify mental ill uses even if they were not directly talking about their diseases. And for machine learning in general, it is important to look at what your machine learning model is learning and do a feature analysis, because in our case, we were able to learn more about language use and mental health, and we were able to see some of the previously known language patterns, and we were able to identify some new patterns as well, like the use of conjunctions, intensifiers like so much, and for PTSD, the use of personal pronoun, past tense, and past participle verbs. And there are some undesirable biases that the models learn, like our model was somewhat biased towards military-related PTSD issues. And on future works, we want to analyze the different applications, the feasibility of them, and the privacy implications. Yeah, if there's more questions, I would like to take them up.
So we have 10 minutes for questions.
Okay, so thank you for the talk. So just a couple of questions about feature selection and data. I saw that, for example, you had stop words like "and" as very significant words in there. Did you try just removing all these stop words, including the days of the week, or were they just too significant?
So we actually didn't, function words were actually one of our features because previous literature shows that it was like these sorts of words, like personal pronouns, for example, which are usually removed in other NLP tasks that give out valuable information. So that's why we kept those features to see if there's a significant difference.
I see. A second but related question is about learning the style. You had one slide on that. I remember you kept learning also the structure of the sentences. But what about like more automated approaches? For example, in NLP now there's talk about learning the style and a style transfer of a particular passage to some other passage. So learning the style of a writer and trying to apply it to something else. But have you ever thought about learning the style of people who have PTSD or who have clinical depression?
Yeah, so based on literature, some of these feature sets are used in, for example, authorship attribution, like part of speech tag bigrams and things like that. But we didn't look at like the particular approach that you mentioned, but something that we could do in the future. Oh yeah.
It's okay. I can go whenever. First of all, thank you for setting up our next talk. I have actually a more technical question though about something you said earlier in the talk, which is about how you tagged the tweets that were specifically talking about depression. What was your accuracy for that model? Why didn't you use something more basic, like just looking for diagnosed, depressed, whatever, things like this? And how did you validate it?
So the accuracy for that, we had like really good recall, so we were like sure that most of the tweets that are related to depression and they were removed. Some of the false positives were things like depression related to weather. So we didn't really like focus on that. Yeah. And what was there like a second part? Yeah, it's hand labeled between two authors, and then we had a high inter-author agreeability.
Okay, so Carmela.
Oh, I'm sorry.
In the 60s, they developed the DSM checklist as a objective way to analyze whether somebody had a mental disorder or not, because they had seen how faulty and error-prone human diagnoses were of mental disorders, and but there's a minority group of people within the psychiatric community who is worried that actually what these feelings of mental disorders are actually normal human feelings of discontent, that we're diagnosing as mental disorders. And it's very interesting because I'm seeing in your diagnosis through patterns of speech a very similar trajectory in the development of psychiatric diagnosis. And the question I'm wondering about is, by diagnosing the population of society, maybe there's a tendency when people are feeling weak or vulnerable to want to be diagnosed, to want to have some kind of disorder as a kind of sense of comfort that there is something wrong that can be fixed. And I'm just interested what your thoughts on that are. Is there some kind of danger of creating a feedback loop where we end up diagnosing society and also at the same time actually creating mental disorders where maybe before there wasn't a mental disorder?
Yeah, so I'm not like a medical professional, so I mean, I don't know how I could answer that. But what we want to do here is like to create awareness and to analyze like what would be the potential privacy implications, because we do see this as a serious problem, and what can be done about it, and that's some of the things that we want to study in the future.
Thanks. So Carmela had this question, but for some reason she wanted me to ask it. So
Goldberg always works better. Yeah.
Okay. So with the tenfold cross-validation you have here, was that you randomly took a tenth of the tweets out, or you randomly took a tenth of the people out? Like, did you ever train and test on the same people?
So this particular one where we labeled tweets to remove from the dataset, that was on individual tweets, but the cross-validate, like the results for, like the main results where we showed the accuracy of the main system in diagnosing depression and PTSD, that was based on user level, not individual tweet level.
So did you do, was there cross-validation on that?
Yeah, so these were cross-validated.
Okay, so
and these were results of individual
people
users.
Trained on other people and then showed it people it had never seen before.
Yeah, yeah.
Good. Yes, I also have capital opinions on the question about like what is depression and what is mental illness, but I don't think now is the time.
So I have depression. It is pretty well treated these days, and I'm doing okay. If anyone wants to claim there is no such thing, or that it's a made-up illness, I would like to introduce them to a number of very intense engrams in my vocal patterns. But what I would like to hear is, how, if at all, is this work supposed to benefit me?
So we want to prevent, like we want to sort of identify the misuses of, since there have been studies on that this can be, I mean machine learning can be used to do this, we want to know, okay, we want to understand the privacy implications and analysis to see why and how this happens. And going forward, we will be able to study like the deeper privacy impacts and probably suggest some methods to technically prevent this, rather than, like, for example, social media platforms have different policies to, for example, not have advertising. So that's something we want to like look at.
So this is in some sense a follow-up to Nick's question. One of the real benefits of the internet has been the ability for small communities to sometimes communicate anonymously for communities like. Sure. One of the real benefits of the internet has been the ability of small communities to communicate, and sometimes to communicate anonymously. It seems to me this kind of work has the potential for shutting them off, for telling them that they will be discovered as being depressed and labeled, and instead of having an outlet to communicate with people like themselves and share, we're doing exactly the wrong thing by doing this kind of work.
Yeah, so I want to like mention, like, this kind of work had been done before, and so our idea was to see why they work, and by doing so, understand the privacy implications. And maybe Rachel wanted to.
To follow up on that, yeah, we looked at this study that had been done in Johns Hopkins, and we had exactly the same concerns that you did, and we said, well, maybe it's not. Our hypothesis is maybe this isn't a big deal. Maybe all it's doing is detecting the content, that it's and that was what we've and just detecting, like, okay, these people are talking about their things. That was what we actually expected to find. And then we ended up finding these sort of underlying patterns. I do think that there's sort of some perhaps benefit in the fact that we've discovered new linguistic patterns that may help clinical research, help clinical diagnosis and so on. But I do find it somewhat troubling, and it's not clear where we're going to necessarily go from here. But we came at it from the approach of saying, with that concern, saying, is this actually the problem that it seems to be, that, or is it just like detecting the word depression or whatever? So, and this was what we found.
There's one last question.
Yeah, hi. I'm just slightly worried that you're trying to classify something that isn't inherently that easily classifiable, and I wouldn't underrate domain-specific knowledge about this. The DSM has quite a controversial history, and I think these things really require a domain expert to collaborate with if you're not doing that already.
Yeah, so I mean, in our initial work, we did talk with some of the people who had done psychological studies, but definitely it'll be something that we could work on in the future. Yeah, thank you.
Okay, so that's the end of this talk. Let's thank the speaker again.
Okay, just a quick public service announcement for the people listening in at home or hear your questions. So whoever's asking a question, if you can speak directly into the microphone, and hopefully it'll pick up your voice. Thank you.
Okay, so next speakers are Seda Gurses and Rebecca Oberdorf, and they're going to talk about bots. The revolution will not be optimized.
All right. All right. Hello, everyone. Our proposition today is to discuss a new class of technologies to protect people in the era of optimization systems, POTS. Now, depending on what age or what kind of geeky background you have, you may think POTS is this, or potentiometers, or honeypots. But we want to talk about POTS in the good company of pets. POTS are necessary because the types of information systems we have today are undergoing a fundamental shift. This shift is not just about processors and bandwidths becoming faster and storage becoming cheaper, but a shift in the way we engineer and develop systems. In particular, in the 90s, software engineering shifted from shrink-wrap software and PCs to services and clouds, and together with that to agile methods. Now, that may seem self-evident, but let me just take a little survey in this room. Please put your hand up if you know what shrink-wrap software is. That's pretty good. Okay. Put your hand up if you use DVDs. CD-ROMs? Diskettes? Have you ever installed from a diskette? Wow, that's pretty amazing. All right, that's really great. Okay. If you were a developer in the 90s, what were the time intervals between the release of different versions of the software you were working on? Call out numbers.
Years.
Years. What else? Who else? 1 month. 90s. Oh, well, okay, come on. All right, so here's our depiction of the 90s. In the 90s, this prototypical tech-savvy dude would walk down to the local Radio Shack, by now I believe no longer existing, to satisfy his software needs. The software came in a box which contained diskettes. This box had a plastic wrap, the shrink wrap software. Undoing this wrap meant the dude magically transformed into a user. It was a contract. From the perspective of the software engineers in the 90s, once the software was in a box, it was out of the hands of the developers. Once a new version was released, the developers entered a post-release depression colored by complaints for all the bugs and mishaps, which they then set out to fix until the next version, which indeed was often a couple years later. These were dark times. Then came the web, and we came to look like these pastel-colored happy people around a table. The shift to web services and applications enable architectures that incorporate real-time feedback from users. Now, the code remains with the developers, meaning updates can be pushed out frequently, and features could be developed incrementally. And all of this could be measured using the feedback loops. This meant a lot of data. And with that data, machine learning started swallowing software engineering. Services today are made of layers and layers of technologies metricized under the authority of objective functions. Objective functions drive software engineering from head to toe. Selection of software features, service integration, cloud usage, user interaction, user growth, customer service, environmental capture, so on and so forth, are continuously metricized, experimented on, and optimized. In other words, it isn't just those evil advertisers that need the data. Data has become the bread and butter of software engineering. So maybe you're familiar with the term ICTs, information and communication technologies. This is how we've come to describe the systems that are around us. They're focused on storage, processing, and transport of information, and organizing knowledge. So by virtue of knowledge and being able to know things, we associate information systems with risks of surveillance. In fact, privacy-enhancing technologies are a response to the perils of surveillance through information systems. But these new systems are radically different. They leverage the knowledge they gather not only to understand the world, but to optimize it. They seek to extract economic value through the capture and manipulation of people's activities and environments. They treat the world not as a static place to be known or surveilled, but as one to sense and co-create. Optimization sounds, well, optimal, but it turns out social and environmental manipulation at scale causes social risks and harms at scale. A short list of these inadvertent side effects of optimization systems includes social sorting, so sorting out people who are not optimal to whatever your bottom line is, mass manipulation, for example, of news and political systems, asymmetrical concentration of resources in a few companies that have become global monopolies, dominance of majority populations, and erasure of minorities. So in the vocabulary of optimization, because these are somewhat different, these harms arise due to choosing inadequate objective functions. And the great thing is computer scientists are writing about this, especially in the AI safety community, but they say these things are accidents. We actually say they're bad design. Inadequate objective functions in the process of increasing the company's bottom line may improve people's ability to most efficiently conduct asocial behavior, optimized for some part of the user population, which may increase the cost for other users, non-users, and the environments that we live in. Now, we can discuss the whole list, but I'm going to focus on the first three with concrete examples. So I'm going to turn to a location-based service called Waze. Companies like Waze can now have different business models because of the shift to optimization systems. Waze-like services no longer just track and profile individuals to generate spatial intelligence about certain areas, people, and their trajectories, which a lot of advertisement companies did in the past. Location services today leverage their systems to manipulate users' behavior and create ideal geographies that fit the interests of their investors. Population experiments using techniques like A/B testing drive iterative designs that ensure sufficient gain for most Waze users while maximizing profits. So what does Waze do? It basically reroutes its users when there's congestion on a given road, allowing these users to act with perfect selfishness. In some happy universe, this could be a socially optimal outcome. Everybody's trajectory is optimized. But traffic engineers have shown that traffic beating apps might work for an individual, but they often do so at the cost of making congestion worse overall. So to optimize travel time, Waze often redirects users off major highways through suburban neighborhoods that cannot sustain the heavy traffic. While this may be useful for drivers, it affects neighborhoods by making streets busy, noisy, and less safe. In this case depicted here, Waze directs Los Angeles commuters to a 35% grade steep road that has gotten drivers in somewhat precarious situations. So these include cars flying into people's front yards and living rooms, a matter that some may find not so optimal. So consequently, due to Waze, towns may now need to fix and police roads more often. With such systems, even when users benefit, non-users and the environments they inhabit may bear the ill effects of optimization. In fact, Waze may not even benefit all of its users. Coming back to the study by the traffic engineers, when the percentage of drivers with access to traffic information is low, so a few people have Waze, then they're all hunky-dory. They get everywhere faster while leaving the masses behind. But as the number of Waze users increase, the benefit decreases for users and non-users alike. So what could we do for these people, Becca, and environments that are impacted by optimization systems?
Okay, so now that Seda has told you all the problems that we're facing integrating optimization systems into our lives, hopefully she's convinced you, let's talk about what people are doing to fix it. We're calling these methods that people are using to fix these mistakes in optimization POTS. We found a number of examples of people fighting back against these optimization systems. For example, with the Waze example that Seda mentioned earlier, people are fighting back against the congestion in their towns. In this one case, a resident of a street affected by Waze created an account to report false traffic data like congestion, accidents, and construction every morning during rush hour, and then again every afternoon. It took Waze about 2 weeks to ban his account. More sophisticated attacks have been shown to be possible. There was a group of students, a research group in Israel, who created a bunch of fake Waze accounts and then spoofed their location all to the same highway location. So now Waze thinks that there's a bunch of people stopped on the same highway at the same time, tons of congestion, super bad. So it redirects all of its users off of this highway, and then you can drive down this nice empty highway void of Waze users. So we're calling solutions like these POTS. POTS are protective optimization technologies. Right now, the methods that we've looked at and we've seen kind of happen in the wild are very ad hoc. They're generally temporarily effective, like 2 weeks. Our overall goal here, though, is to be able to design tools to benefit users and non-users of a system who are suffering the ill effects of optimization systems. So by now, you're all on board. You've heard from Seda the harms that optimization systems cause. You've heard what people are doing already to fight back. And the only thing you want to know is, how do I make one? Go.
Thanks. Wait, put the picture of the cat back up.
Sure, sure.
Thanks. Okay. Okay, so my actual question is, so is the goal to produce an optimization technology just one that has a better social effect, or is it to subvert optimization technologies? And if so, what are you optimizing for?
Right. So I kind of just want to go on with the slides.
Okay.
We're going to answer that question in the next couple of slides.
But the first answer is no, and the second answer is yes. So how do you design a pod? First, you're going to want to define your benefit function. This function is a result of the optimization system without a pod. This is not the optimization system. This is probably not the benefit function that the optimization system is using. And it takes into account things like users, non-users, environments, and the output of the system. Depending on the pot, there may be more or less of these parameters. And again, it doesn't have to match, or probably doesn't match, the optimization system of the function, because we're not designing better optimization systems. We're going outside of them to fix them. So for example, for Waze, we have certain users that have a high benefit, like this very happy puppy on his fast commute to work. And we have others at the lower end of the benefit function. For example, this is one of the pictures from the article that Seda talked about earlier with this 35-degree slope in LA, where people's gardens were being run into, people's porches were being destroyed by people going down the street too fast, where they wouldn't have otherwise gone. Okay, and then next we want to identify the inputs of the system, so that you can figure out what you can change. So for example, with Waze, I lost my mouse. There we go. Sorry. So example, with Waze, we can make the system think that there's an accident or roadwork on the street, which is artificially changing the inputs that the system has. And then we can build a pot that changes these inputs and evaluates how well it works. And we need people like you, pets people, because pots, like pets, need to be effective, long-lasting, and stealthy. And I think the pets community is quite good at these 3 things. Okay, next. There are multiple strategies for changing the benefit function depending on the overall goal of the pot. So in the top right corner, we can correct the imbalances. So for Waze, maybe we can figure out ways to stop directing people on these super optimal but dangerous routes, so that brings the puppy's commute a little slower, but at the same time, nobody crashes into the front yard of one of the people in this neighborhood. And so that would be this green line in the top right, where we can kind of correct things. If we don't have a scarcity of resources, we maybe even just be able to elevate everyone. On the bottom right, maybe we want to do something more like a protest, where we flip everything around. And the people who weren't getting any benefit before are getting the most benefit, and the people who are benefiting the most get nothing. Or my personal favorite, we can just sabotage the whole system so that the benefit function is messed up for everyone overall, because maybe this is an optimization system that we don't think should exist. Good. So here we have our system model for pots. On the left, you have an optimization system without a pot. As input, it considers its users and some constraints, such as the environment, and from these variables, it decides some output. And on the right, we have a system with a pot. The pot changes the inputs in order to get the desired output. The pot can be induced in training, which you can think of maybe like a data poisoning attack, or it can be something more like an adversarial test example. There could be many more of these. We're open to it. So hopefully now we've taught you what pots are, why you need them, and how to make them. And you'll think about making some pots. Maybe you already are making pots. We have some things that we can discuss if you guys have some questions. We'll see you next year at Hot Pots. And special thanks to our co-author, Errol.
Any questions? So I was wondering what reaction should we expect optimization system providers? It seems like some of the pots would be like maybe infringing the service terms of the providers.
Oh yeah, definitely. So I mean, I think that this is actually kind of something that Pets has to deal with as well, which I think is why we wanted to present it to this community as an idea. The hope is that we have some system that we can't change inherently, but we can kind of change from the outside. And the hope, in some cases at least, is that our changes from the outside as we're coming at it force companies and organizations to rethink about how they do optimization systems and what and who benefits and doesn't benefit from their system. Or maybe we're going against their TOS or something, and then it's a different problem, but I think that's a problem that the community is familiar with.
I was reading the other day that the US military are designing these new robots which they can run and they can walk all over all different kinds of terrain. And and they say that for the moment it's just because they want to do reconnaissance, but it's pretty obvious that eventually they want to have walking and running robots that will carry heavy weaponry in a battlefield. And there was an outcry recently because they were also developing a subsystem, which was a way for the robots to be able to eat and digest biomass. And so people obviously thought, well, if this robot is built for killing human beings, and it can also eat the human beings. It's kind of like a question of like, well, why are we building these kind of things? And we live today in a society like the Western worldview we live in it have a lot of power, the way that we can reduce reality. Like, as much as we talk about science being about understanding the cosmos and the universe, science is about giving us some form of power over nature and over other human beings. And we like reduce reality down to a mechanism that we can fully study and exploit and understand, but it can't answer us for why do we do these things. And obviously you guys are in that area between technology and ethics. Right now there is this general feeling it's the reason why there's such a high level of mental disorder in the society, that we've just been reduced to a bureaucratic system of mechanical control where the human beings are just cogs in a machine, and the only way that they can think to go forward is to be a bigger cog and just to expand and to grow and to grow. And now the technology is getting even more powerful to be able to develop new psychological techniques to get people to spend longer and longer time inside of these platforms, to click more, and have this huge labor force which is not able to comprehend these gigantic political and financial interests that are manipulating humanity. And it's interesting talking, there is some technique or mechanism that they're using, and how can we throw a wrench or a hammer into that? But how do we go forwards from that? How do we get the technology world, which at one time had a lot of power in the 90s, and in the 60s was really driven by a sense of trying to get access to this computer technology, to use it to improve humanity and to drive humanity forwards, which has now been reduced to withdrawing to hacker spaces to make cat ears or funny little toys. Like, how do we reinvigorate this movement with a sense of vision and destiny once more?
Okay. Should we take that as a comment, or should we? No, I mean, depending on your mood, of course, there is the sabotage option, if you haven't noticed, but
throw wrenches.
yeah, it's totally an option, right? Yeah. Oh no.
So I mean,
one of the ways of viewing the current political system, political issues that are going on now, is this radically different views of what it takes, what constitutes to optimize society and how those trade-offs should be made. And it's not getting easier to do that, it's getting much harder. So in light of this, how do we move forward?
Okay, so I think what's happening is with optimization systems, we go into like a super utilitarian logic. There's some people who are saying, if with autonomous cars, instead of, having 35,000 people die in accidents, only 5,000 die, isn't that better? We actually reject this kind of logic because I think it doesn't, every life matters. And if we just think in these kind of instrumental utilitarian views, then we're doing injustice to certain populations just by virtue of thinking we increase and decrease numbers. So we would disregard this kind of optimization logic as a way to organize society. This doesn't mean that we shouldn't have optimization, but the point that we're trying to make, there are many points we're trying to make with this paper, but one of them is that you cannot have a centralized entity that can think of all the subpopulations and all the sub-effects of optimization systems. So you need to have external channels through which optimization systems can also be challenged. And if you don't have those external channels, you don't have a democratic system which can be challenged, or the governance of which can be democratized.
But it may be that we're over-optimized and that this is the reason why things are so difficult now. There may be too much structure in things.
Yeah, so throw wrenches.
Yeah.
All power to the people.
So I'm trying to understand the difference between pots and pets, and if you're trying to sort of, encourage a paradigm shift. And I'm not sure. It seems like, so I'd just like to point out historically, after Snowden, there was a huge shift in interest in privacy. And the goal was to sort of prevent nation-state actors in general from doing large-scale mass surveillance, because it will probably lead to something such as, a second Holocaust or lots of death by nation-state actors. Now, in the machine learning and fairness paradigm, seems to be more focused on, given that we're using optimization techniques in large parts of society, social services, et cetera, we want to defend people's civil rights, their equality, equity, right to a good life, from being unfairly and discriminatorily targeted by sort of machine learning algorithms, by optimization techniques. These are actually, I think, two fairly different paradigms which haven't been properly connected. It seems like PETS was originally aimed at the first, is now aware of the second, and I'm not sure exactly, is POTS trying to aim at sort of essentially preventing unfair optimization? But then to some extent, is that actually a larger problem or more important problem? Or is it just like a neglected secondary problem to the things which PETS were built to do to begin with?
Yeah, I want to say that it's not a subset of PETS. I think that we're at PETS because there's a lot of overlap in what the PETS community does and what we think POTS should be. We also think that we need a lot of PETS technologies built into things like POTS. And maybe Seda has more to say on this, but.
Yeah, so I think we tried to show the shift from information systems to optimization systems. And information systems, you still care about knowing things. And you can imagine that privacy is still important. If you don't want something to be known, you don't want it to be in the system, right? But the optimization systems also completely transform surveillance in the sense that if knowing things in the past was a way to surveil people, optimization systems are about predicting things in the future so that they can stop you or manipulate you into doing something different. To give you an example, if there was going to be a way to predict demonstrations happening, it doesn't matter that the system knows who you are. It's the fact that you're seen within the pattern of a demonstration potentially happening, and it's the ability to manipulate you not to go to that demonstration that is now at stake, right? And so that's a very different form of surveillance that is transformed through optimization. So I think classical PETs still have value, confidentiality has value, being able to keep events that can be inferred and predicted confidential has great value, but optimization systems transform surveillance so much that we might also have to transform the kind of things PETs can do.
So, sorry, I was curious to know if for the case of Waze, because of the bad press, did the company...
We can't hear you. Speak up a little.
Yeah, sorry. For the case of Waze, because of the bad press, do you think there is a hope that the Waze will also include some social cost in the optimization, or do you think it's not a solution?
I don't think that they will. I'm speculating. But a lot of the communities that have been struggling with with kind of the bad end of the optimization for Waze have tried to work with Waze and haven't gotten very far. And so, no, I'm not optimistic about Waze making their system worse for their users in favor of some non-users that aren't considered in their model. But maybe I'm a pessimist.
So you think maybe regulation by a city or country could be a way, like to force company to include some social implication, or?
So would regulation help? Will we regulate against it?
Yeah, I'm just asking if some country or city maybe have tried to say, okay, we're gonna ban Waze except if Waze is gonna
Cities haven't been successful. The one kind of regulation way that this has been dealt with within cities is that we found some cities putting up signs that say local traffic only. There was one city in New Jersey that gave the people who lived on this street little yellow cards to put in their windows. And then if you didn't have a yellow card, you would get pulled over and fined for, because says no through traffic. But this isn't punishing Waze in any way, right? It's punishing its users. and maybe they lose a few users to this, or maybe these people just learn not to go down this street and they keep using Waze. I'm not sure, but this is the only kind of regulation or laws that we've seen in this way.
So, wait. So, I guess a question concerning something from both your presentation and some of the questions. I worry that you've kind of over-optimized on optimization or something like that. You kind of seem to, how to say this coherently and succinctly. It seems like you have this choice of just saying, okay, let's just look for these ways to, interrupt optimizations wherever we think, hey, maybe there's a problem, and then you run the danger of, just, man, let's tear it all down, and then we'll just sit here and groove on the rubble, to paraphrase a David Fry album for the other very old people in the room like Jeremy. Wake up. Or you have this sort of problem that what you end up having to do is effectively meta-optimize, because you have to decide when it's a POTS that is worth pursuing and when it isn't. So I worry that you found some nice, very good, salient examples of, clearly you optimize on a particular thing, and then, that left out a lot. But without some level of optimization, you don't have things like this building or the mechanisms by which we all got here physically in this room.
Right, so welcome to our backup slides. We actually spent a lot of time trying to think about this idea of if we're just re-optimizing optimization systems, the same problems still exist, right? Like we might be able to, if we go back to the benefit curves, right, there are still going to be people who are losing out in all of our schemes, probably. Maybe if there's no scarcity of resources in some weird perfect problem, we can get this blue line in the top right corner. But in general, we don't think that's super realistic. And so there are, I think, any ethical problems that are existing within the optimization systems themselves are probably still existing in POTS. And I think that's something that we need to think about a lot.
So it turns out like the history of optimization systems always comes with counter optimization systems, right? There's never an optimization system that exists happily. The good example is search engine and search engine optimization. And so the point is, and this is a really hard political point, which also we've encountered with pets, is that if we want other people to also be able to optimize and not just people who have money and who can pay for counter optimization, then is there a sort of a reason for people like us to be working on ways of making POTS available to a greater audience than, for example, people who have money?
So POTS is, it is still doing optimization. You're just optimizing for something different. And I think...
Sometimes.
Is there, well, I don't know about sometimes, right? Whatever you're trying to do, you're trying to do something, and that is the thing you're optimizing for, right? Taking a very broad view of what optimization is, right? It's basically you're trying to get to a goal, and maybe you can't get the goal, but you want to get as close as possible. So you have some metric in your head for how close am I to my goal, right? And so I'm wondering, how can we take a lesson from pets where, for example, initially some very nice work was done on using entropy, for example, to measure the quality of a privacy-enhancing technology or the amount of anonymity in a system. And then over time we realized, well, it's not the entropy, which is like a global average, that really matters. It's something akin to min entropy, or how good does it do for the worst person, right? Not the worst person, but how good does it do for the person who benefits the least, right? And maybe that is one thing a POT might want to optimize for example. So can we take a lesson of global, so most POTs today are most optimization technologies today are optimized exactly for the opposite. They take a small set of people and they want to say, optimize for these people, whatever it happens to everyone else doesn't matter. And maybe we want to look at what PETS has learned and say, optimize the global minimum, raise the global minimum, and see what happens.
First of all, we really like the way you've already internalized the term POTS. So, do you want to say something about the benefit function?
Yeah, sure. So, I mean, yeah, so one thing that we kind of made sure to talk about, one more? Okay, sure. So one thing we wanted, that we, kind of the first thing we said when you make a pot is figure out who's losing out, right? And then try to fix the bottom of the benefit function. Kind of maybe at the expense of the top, hopefully not at the expense of someone in the middle. But so I think that kind of in the spirit of this idea of kind of your minimum entropy, your person at the minimum of the thing, that's what POTS are essentially from the very beginning aiming to do.
So that's just one choice, right? You could make other choices.
Yeah.
Like that one, like the sabotage.
Yeah, well, the sabotage choice, yeah. But this is more of a mess the system up thing, kind of, right?
Which is
it's a
goal
wrench.
in itself, right?
Yeah.
You're messing it up because you want to achieve a larger goal.
Yeah.
Right?
Yeah. For what? Your mic isn't working, so just speak loud.
Guys, it seems like POTS could be used and are already being used for equal purposes.
Yeah.
And I think maybe use batteries are a good example of a equal pot. Maybe. Is there some notion of a counter pot or a second order pot? If you could figure out a counter.
We don't hear.
So we'll repeat it.
Yeah, go ahead.
So, yeah. What did Tarek say?
I don't know what I think repeat the question.
Okay. All right, so he's saying, aren't POTS used for bad too? And aren't they already being used for bad?
And can you have second order POTS that correct the bad POTS?
Can we have POTS on top of POTS? Within POTS?
Why not?
With pets?
Yeah.
And I think we can talk about this in the context of pets as well, right? Which is like there are kind of misuses of pets in the same way that there are misuses of POTS.
Yeah, and also we've kind of noticed that within the research community, adversarial machine learning often assumes that the users are the adversaries, and we wanted to have a model where we wanted to see the ones who are running these large-scale optimization systems to be the adversaries and the users trying to protect themselves. So that was part of what we're trying to do.
So, very nice work. I'm glad you have that slide up right now because I'm trying to figure out sort of the broadness of this framework. So, which pets are POTS, which pets are not POTS? Like, is the Tor network a POT?
I don't think the Tor network
I mean, what about the browser, the Tor browser that changes, the way that your browser fingerprint looks to then disturb perhaps.
Okay, that's a POT.
Yeah.
Things that I think are POTS. Ad blockers, we think are POTS. Tor, I don't think in and of itself is a POT. I think something that counters fingerprinting techniques is a POT. Other pets that are POTs.
Like Tor pluggable transports?
Where's the optimization?
Well, it's overcoming censorship circumvention.
Sure. What pets are POTs, what pets aren't POTs, etc. And pluggable transports. Are pluggable transport POTs? I don't see the optimization that you're fighting against there. I see kind of a system that you're fighting against, but not necessarily some sort of optimization in what you're losing out. At least not a technical one.
Okay, I'm sorry. I think we are way over time, so we will have to take all the questions offline. Hello? Hello?
Okay. Hello, people. Thank you. We're going to have our keynote very soon. There's just a quick announcement I forgot to mention in the opening remarks that every year we give a Best Talk Award. So they'll be voting at the end after all the talks. So just keep in your mind when you see something nice that you can vote for that talk to win a nice prize. All right, thank you. George?
Hello, I'm George Danezis. I'm chairing the invited talk session. And it's a great pleasure to welcome Joris van Hoboken here. Joris is a professor at the University of Brussels. He studies law and also public policy in many respects. And he will tell us all that we ever need to know about the GDPR. And in particular, is it a good thing or is it a bad thing?
Thank you very much for that intro, and thank you to the organizers for having me here to give a talk. I'm a big fan of the PETS community. I've been to the PETS conference a few times now, and I think it's one of the key conferences for also for legal people to follow to see what's happening in terms of privacy technology development and discovering of new technical privacy issues. So it's a big honor to be here. I'll be giving a talk about the GDPR. The GDPR that I guess who hasn't heard of the GDPR in this room? It's basically no one. So yeah, this has been quite a ride, especially the last months with it entering into force. So I'm gonna try and do. As good of a job as I can of telling you something about the GDPR in a way that I think would be interesting for your community. So let's hope that I'll manage at that. So yeah, I'm a professor of law at the Vrije Universiteit Brussels. I was there appointed to the chair of fundamental rights in the digital transformation in last fall. Which is a new chair that is established at the LSTS group, that is the group that organizes the CPDP conference that many of you may know, and it was established with the support of Microsoft. That is a part-time position. For the other 50% of my time, I'm at the University of Amsterdam at the Institute for Information Law, where I also did my PhD research on search engines and freedom of expression. So just a quick overview of what I want to do with my talk. First, I think it's important to talk a little bit about the basics of EU data protection, put the GDPR into context, and hopefully clarify that a little bit more. It's like what place in the legal landscape, in the European legal landscape, the GDPR has, and then also speak a little bit about what are the main legal ingredients of what is in the GDPR. So then I want to focus on what are really like the important changes in data protection that have been introduced by the GDPR, and there I will obviously also focus on some of the things that I find most interesting, and also some of the things that I think are most relevant from a pet's perspective. Then I will talk about some developments in enforcement and compliance. So the GDPR has really changed the enforcement and compliance context quite a bit. There's a lot more pressure, and things are moving in a particular direction. And there's some interesting things also to be said about civil society action that I want to talk about. And then we'll move on to some perspectives on pets and the GDPR. So on the EU data protection basics, yeah, I ran into this very funny report about an app that actually, so this is one of those mindfulness or relaxation apps, and one of the things you can do is listen to the GDPR. It's actually a BBC News reader that reads the content of the GDPR. And I think there's something going on here, of course, that is like these app developers, they run into the GDPR, they have to do something with the GDPR, and I think there's something of kind of poking at it and not being too happy about it. But I think it's also the fact that the news picked up on it like this and just make it seem that it's something very boring. There is actually, if you read it carefully, there's quite some very exciting things that you may run into and that you could use also as a basis for research, including technical research, or all sorts of campaigns that you could do. So I think it's a bit of an overstatement that you would fall asleep. If you would really read this with an interested mind, you may actually lighten up a little bit. So, on the basics, so national data protection laws, they exist in Europe since the 1970s. Hessen, a part of Germany, Sweden, France adopted data protection laws already in the 70s. Then after this, there was development of international data protection standards, for instance, in the Council of Europe context, in what is called Convention 108, which was also recently amended. A new version was adopted. This originally was adopted in 1981, and also in the OECD, which is an international organization that includes the United States, principles were adopted in the 1980s. So EU-level data protection already exists since 1995. And in 1995, the member states acted to harmonize all the national data protection laws in the interest of the internal market, so there could be the free flow of personal data within the European context. So this harmonization exercise resulted in the Data Protection Directive. A lot of what is in the directive is still there in the GDPR. Actually, the GDPR leaves a lot of the directive unchanged, and I think this is very important to realize, that it is not that we suddenly have this whole new law with all sorts of new principles. That is really not the case. So, and then very importantly, the right to protection of personal data was codified as what is called a fundamental right in Article 8 of the EU Charter of Fundamental Rights. So for US people here, this is for Europe, this is the Bill of Rights. This is these are specific provisions, constitutional status, fundamental rights. So it's really the protection of personal data is elevated in the legal domain to this fundamental rights status. This first was declared, solemnly declared. It wasn't binding yet in 2000, but it then became binding since 2009. And that's a very important element of European data protection law. So I put that, because it's so important, I put it on a slide. So Article 8, protection of personal data. So this is a separate right from Article 7, the right to protection of private life. It also includes the protection of confidentiality of communications. But now we have this separate right on the protection of personal data, and it says quite generally that everyone has the right to protection of personal data concerning him or her. This is in relation to government processing of personal data, but it's also in relation to private sector, which is quite important. You call that horizontal effect legally. And such data must be processed fairly, for specified purposes, and on the basis of the consent of the person concerned, or some other legitimate basis laid down by law. Everyone has also the right of access to data which has been collected concerning him or her, and the right to have it rectified. So here you basically, some of the elements that you have in data protection law have been put into the fundamental right and just elevated to this higher legal status. And then additionally, in the third section, compliance with the rules shall be subject to control by an independent regulatory authority. So the independent oversight is also part of the fundamental right. But what does it really mean for protection of personal data to be recognized as a fundamental right? So I think one of the ways in which you can see really the implications of this is what the Court of Justice of the European Union has done over the last years in a number of really far-reaching rulings that really strengthen the right to privacy and the right to protection of personal data in the European Union. So first of all, the Digital Rights Ireland case from 2014, which resulted out of strategic litigation from civil society against the Data Retention Directive. The Data Retention Directive, which was adopted in 2006, that had to do with, made it mandatory to store the electronic communications records of people using electronic communication networks. So this is a very widely debated and contested directive because of its wide privacy implications for people using electronic communications networks. And this litigation was in the end successful, but the Court of Justice said this directive really goes against the fundamental rights to the protection of private life and also protection of personal data, and annulled the directive. And so as a result of that, we don't have EU-wide data retention. There are still a lot of countries that are trying to pass new laws. There's a lot of pressure to have some form of data retention, but we don't have it anymore. So then the Google Spain and Costeja case, also known as the right to be forgotten ruling, which resulted in a ruling that said you have a right to request deletion of specific search engine results for name queries, so for people search, even to lawfully published information online. So even though the information that can be found online is legally there, it could be so that you have a right for that information to be delisted from a search result in the situation, that the results are presented on the basis of your name, which is a very radical proposition. And the court developed that proposition based on the understanding that bringing all this information together in a search result page really had this potentially disproportionate impact on people's privacy and reputation. And they used data protection, very basic data protection principles, to ask for the correction of your data, to object to the processing of your personal data. General rights that have not been developed at all specifically for a search engine context, but they interpreted in this specific context as having this effect of allowing you to ask for that, and then developing some broad balancing principles in what situations you actually had to remove. So then on two basic, very fundamental notions of data protection, the court made quite sweeping rulings. First of all, in the Breyer case, Patrick Breyer from Germany, also an activist, he litigated on the status of dynamic IP addresses under data protection law. So the question is that still personal data? The court said yes. And then in a recent case, that is about Facebook fan page, an organization using that, the court interpreted the concept of controller, which is a concept that's basically the controller is the entity that is responsible for the rules under the directive or the GDPR, and really developed that very broadly. And so then one thing I want to highlight is what the court did is they came up with this standard to decide these cases on data protection and privacy, and they said it's basically the standard is that the protection should be complete and effective. And if you read some of those rulings, you see this standard actually being used like somewhat of a deus ex machina. If there is some kind of problem of interpretation, they always they use this standard to say, well, we can't have that interpretation because that would allow you to evade the protection. So then using this complete and effective protection standard to really have very, very strong rulings on the scope of data protection and also on its applications. So the EU General Data Protection Regulation, the GDPR, it was proposed in 2012 by the Commission under the responsibility of Viviane Reding. It was then adopted by the member states in the European Parliament. That's how it works with European legislation. It's like debated between these entities. In 2016, and the rapporteur in the European Parliament was Jan Albrecht, who's a member of the Green Party. And then it entered into force just this May of this year. But there's a lot more data privacy, a lot of more data protection than the GDPR in Europe. First of all, there's, for instance, the Police Data Directive, which was adopted at the same time as the GDPR. So the GDPR is about commercial personal data processing and also public sector data processing, but not for specific part of the public sector. First of all, intelligence agencies, national security is completely outside of the scope. That has to do with the fact that the European Union doesn't have a competency in that area. And then for police, law enforcement, that's also out of scope, and there are separate rules for what police can do with personal data and how they can exchange it. So then secondly, and this is debated at the moment, there are the e-privacy rules. And these are actually rules that are quite relevant for this community because of the focus, a lot of focus on communication systems and internet tracking. So the proposals are currently under discussion for a revision of the e-privacy directive, making it into a regulation. And issues there include like online tracking, Wi-Fi tracking, browser and OS privacy settings, confidentiality of communications, messaging services, and encryption. So then, in the area of law enforcement, lawful access to data, there are proposals that try to address cross-border issues in lawful access to cloud service data, and these are called e-evidence proposals. They've just been issued by the European Commission and are under discussion. So the GDPR, in short, just to give you my quick kind of characterizations. So very shortly on the substance, the GDPR, it aims to ensure the fair, lawful and transparent processing of personal data by organizations operating in the EU or processing personal data of people residing in the EU. So you could be somewhere else, but you're focusing also in the EU as a market. And making that also subject to independent regulatory oversight. So that's really like the general basics of it. So then what type of law is this? So it's comprehensive. It's an omnibus regulatory framework. You say, instead of having maybe a vertical approach where you say, we're going to regulate what is being done with personal data in the financial sector, we're going to do it in the health sector, in the educational sector, or what municipalities can do with like government services, and have specific rule sets and frameworks for those particular contexts that also present, of course, particular privacy issues and have particular types of systems that may be implemented. Instead, this is a very sweeping, general, comprehensive regulatory framework. And it stipulates broadly applicable, quite interrelated and general obligations and rights. And as a result of that, there's quite significant legal uncertainty about their appropriate interpretation in specific contexts. And so the rules are actually so broad that it takes a lot of work to know what exactly they mean when you like apply them to a particular data processing operation. It's 88 pages, the GDPR, in what is called the official journal, so like that's where the laws are being published, stipulating 99 articles and 173 recitals. Those recitals are, let's say, explanatory considerations. They give you a little bit more background of like about the law and about the actual provisions. And the GDPR was adopted in a very heavily lobbied process in which more than 4,000 amendments were tabled. There's actually a documentary about the process that was made. So they're really quite, and this has surprised a lot of people that have been involved, policymakers, government officials, politicians, that the end result is really quite strong. So really relatively strong protections in the final text. And I don't think that for a lot of people that, I mean, why are proposals made? Why is there a GDPR? It's like there's not that much change in relation to the directive. And I think a lot of the people that really pushed, like the political push to do a new version of data protection law at the EU level, the anticipation was not that it would suddenly become this super strong text. Now, that was not the strategy of some of the powerful entities pushing for a new instrument. I have the sense that one of the main goals was actually to create a much more transatlantic personal data space to resolve some of the international issues, and also to do something about the lack of harmonization. But as a result of quite a combination of events, Snowden revelations happened in the middle of this. Also the European Commissioner that was responsible really taking a very strong position on privacy and the importance of giving people control over their personal data. A very privacy-friendly rapporteur, that really pushed, like he was from Germany. Generally, German politicians care quite a bit about data protection. And he worked also very closely with civil society. And there was very effective lobbying and campaigning, both by civil society. There's a website, Lobby Plague, that detailed also some of the impacts that civil society had. As organizations like Bits of Freedom, European Digital Rights, Panopticon, they did a really good job in the beginning of influencing the process, but also the data protection authorities and the whole kind of official data protection community of regulators. They had a big influence. Okay. So that gives hopefully a little bit of context. Now talk a little bit about what is the substance. So GDPR is a law that is applicable to, this is really the core thing, processing of personal data. So personal data, that's really quite a broad concept. So this is any information relating to an identified or identifiable natural person. So the two basic, the really important part of this are this identified, identifiable. This community knows a lot about what are the boundaries of that, and how hard it is actually to have, once you have quite rich data sets, to prevent that data from actually using it to identify people. But the element relating to is also very important. This is not just information that is about people. This is also information that is in somehow way linked to a person because it, for instance, can affect that person. It's going to be used to evaluate that person. So this is a very, very broad concept. So then the thing is, if there is processing of personal data, processing is basically anything you can do with information. The question is, who is responsible? And the law has basically two key kind of entities. Conceptually, it's like on the one hand there's their controller. This is really the central one. The controller is the entity that determines the means and the purposes of the processing. And importantly, you can have multiple controllers doing this together. And then there are processors, and these are entities that are doing processing basically under the authority of the controller. So they're basically asked to do something with data. For instance, in a human resources management context, they're being asked to do something with data because of administration, or in the cloud context, there's a lot of processor activities. So then the question is, what are the main responsibilities? What are the main obligations for those controllers? So the first and probably the most fundamental legal requirement is that you have to have a legal ground for processing personal data. So, and one of the legal grounds that is most known and is most well known is the one of informed consent. Basically, a person was informed about what you're going to do with their data, with their personal data, and then said, yes, I'm okay with that. So that is consent, informed consent. But there are multiple other legal grounds, and in many ways they're maybe even more important. They're more objective legal grounds. So these are legal grounds is like this, it's necessary to do what the system is supposed to do. Or it's necessary because we are the tax authority and we have to administer tax and tell people how much tax they should pay and we should check it. So it's based on the fact that there's a law that gives us the authority to be a tax authority and to do this kind of work. Now, and the one that is very important too is the one of contract, which basically the processing of the personal data is necessary to offer you the services that you enjoy. So that has some, of course, similarities with consent because the person is agreeing to use the service, and that implies that there's personal data processing. So then finally there's a legal ground that's called the balancing provision, where you say, I have a legitimate interest in processing this personal data. For instance, I need to make my system secure, cybersecurity reasons, and the risks for the right and freedom of those whose data I'm processing, it doesn't outweigh my interest of personal data processing. So it's like it becomes a bit of a balancing exercise, and there are some specific legal implications of that, because people can say, actually in my specific individual case, I don't think that balancing exercise is in your favor, you should stop processing my personal data for this reason. So then, the purpose limitation principle, so this is also, you saw that in the fundamental right. So the idea is you only process personal data for limited, specific, and explicit purposes. You know, and once you have determined those like purposes, you can also do this legal ground lawfulness exercise and say, do I actually have a legal ground for this particular purpose? Then you have to be transparent about the processing. There's some specific much more strict rules actually for sensitive data. So these are personal data that reveal sensitive attributes. There's actually a lot of debate actually for decades, like how difficult it is to actually really say what is sensitive data and what is not sensitive data. And because of the predictive turn in computing, this has become much harder. So there's like, we can probably see a lot of debate in the coming years still about this particular type of rule. Then accountability. So this is the ability to demonstrate compliance. So the idea is like if you're a controller and you're responsible for these things, you know, it's not that you have to look at that and decide I'm okay. No, you actually have to document like the way in which like you demonstrate for yourself, and then potentially if a regulator asks, that you're actually complying with the rules. So it requires all sorts of documentation and risk management, and also in the principle of accountability, data protection by design is included, which is a new thing. I'll talk about that a bit. Then there's international adequacy. So the idea there is that Europe, like we're great, we have like organized all these data protection rules. Now we have to prevent that this data leaking to places where the protections are not good. You know, so that results in quite a lot of tension, obviously, with other countries, including the US. There was just now like a new decision, I think, from the European Commission on Japan being adequate or not. And then there's another element which is important, are the data subject rights. So these are rights to give people, individuals, access to their personal data, the right to ask for correction when it's not correct, to object to their processing, to ask for erasure in particular cases, the new right to data portability, and some rights in relation to profiling and automated decision making. And then, as said, this is made subject to independent regulatory oversight. So these are national established data protection authorities, and they work together in what used to be called Article 29 Working Party, but it's now the European Data Protection Board. Okay, so these were the basics. Are there any questions at this point? Carmela? What's that?
What about proportionality?
Yeah, so the proportionality is as a principle, you see it mostly in the lawfulness. You know, so the question of, are you allowed to process? So for instance, like, then it's like, it's necessary to offer the service that I'm offering you, and there you have to do a proportionality exercise. But you can also maybe see it in some other areas where, you know, data subject rights, someone asks access to their data. They say, well, for this data, it's going to be disproportionate amount of work to really find all the data for you, so I can only give you this. You see, like in different areas, that proportionality can pop up.
So I've heard this GDPR referred to Act for Privacy Lawyers Act, because your neighborhood tapas restaurant suddenly has to keep a privacy lawyer on staff to ensure that they're not violating some rule. Is that part of proportionality of expressing a reasonableness of the amount of work that a small organization needs to do? So that's my first question. And then my second question is, looking forward 5 years, what do you think courts and the public are going to react when they see how much effort goes into this in cases where the risk may not be very big, like this restaurant leaking their list of customers?
Those are great questions. So there's been quite a lot of debate about like of course, the cost of compliance on this. And it's true, and I will get back to that a little bit. It's like there's basically everybody is a controller. No, so and that every local shop, every local business, all sorts of organizations, they are basically controllers. We are also all controllers. Like we are controllers for maybe the personal data that we post on social media. You know, like for also probably for research that people are doing involving personal data processing. And so then the question is like, is that really reasonable, and where should the focus really be? I think like in a lot of situations of organizations that are made, like let's say a local shop, or like, and they're processing personal data of their personnel, more and more I think they're using not like unique information systems, you know, they're actually plugging themselves into a service environment where a lot of the compliance will have to just be baked into the services. So that solves some of the issues. You also like have the question, of course, do you really need to have a data protection officer? Yeah, so there are some guidelines, like there's the rule of like having a data protection officer as part of this accountability thing, and there you have some boundaries. If you don't do very large scale processing, or you're not systematically monitoring people, you don't have to give a DPO. But what you see is that the rules are actually they are a little bit on the broad side, so there's really a risk of over-regulating and really putting a lot of energy into regulating things that are really not that risky. So there, another thing that could help is what is introduced in the GDPR, is what is called a risk-based approach. Also, there it's really like the idea is that you really go through this risk management exercise, and it could be that you just see like this is really not a big deal. But yeah, this definitely the question of like what is reasonable to expect from different types of controllers is an important one going forward.
So you mentioned that the GDPR is a little broad and little vague, like and the way I see it is like the challenge of like formulating or drafting such laws for each specific case. It just becomes, because technology moves forward so much faster, I think, and so it becomes really hard to really have a policy for sort of each use case. And so how do you draw the balance between what should be a policy versus what should just be left out vague and open?
So this is a great question, and just to repeat it for everyone, the question is like, how do you actually strike the right balance between formulating, like on the one hand, like you maybe want to be quite specific about what you require, so you would like want to maybe design very specific laws that are like really clear about what is required in a specific context, or where like and the obvious downside of that like yeah, things are changing all the time, and maybe like it's really important to actually have the rules on a much more general conceptual level. So I think the answer of the GDPR is that. So this is like in theory how it should work, I think, is that you have those very high principles, and then practice, you know, and these are the controllers in the first instance, they do the work of like interpreting these rules and then making themselves accountable for that interpretation, you know, which of course still allows for pushback. That still allows you to say, you did a terrible job interpreting this rule because like you should have done this. You know, so that is, and then what you have too is like you have this possibility of codes of conduct where you put some of those maybe domain-specific or sector-specific interpretations, you put them on paper, and you that say this is the way that we think the GDPR means for us.
Can you talk a little bit more about the consent requirement? Because if I understand correctly, it's more than just informed consent, but it has to be like willing or something like this, of saying like, I've heard that the GDPR might actually be prohibiting apps from, say, giving you the choice of you can give us your location or you could not use the app. And if the app has nothing to do with your location, that is not actually willing consent anymore, even if it is informed.
Yeah, so that's the element of the consent. It needs to be informed, but it actually also needs to be freely given. So. And there you see a lot of developments, especially like in the tracking walls and things like that, you know, where the question is actually, should you offer the service, you know, like excluding those maybe more pervasive types of like surveillance that come with it. You know, so should you have an option of like going to a newspaper website without like all like tons of trackers on them? And there's been a lot of debate, and this is actually one of the specific issues that the e-privacy regulation is like probably going to give some answer to. So in the GDPR, there's a general provision, and that says, like that kind of extra emphasizes, it's Article 7.4, that consent should be freely given, and that also, like, it means that you're not allowed to bundle personal data processing with the offering of the service. You have then, so what you have to do is you split up that part, and so you're offering the service that has some basic personal data processing that is necessary for the service, and then for additional, let's say, features or things that are happening, you have to ask separately consent, and that's an opt-in. So, and there's a lot of debate about this. I'll come back to this. I'm gonna move on because otherwise there will be, I will run out of time too early. But maybe you can keep your question for the next interval. So I want to talk a little bit about notable changes. So first, and I mentioned it already, there's more harmonization. And one of the ways this happened is we moved from a directive to a regulation. The directives have to be implemented. Regulation is just directly applicable. But there's actually still a lot of flexibility remains, and especially that's the case in the public sector. In the whole regulatory process, all the political debate and focus was like all these tech companies and private sector and what is happening with our data, and actually not that much focus on what is happening in the public sector. That has a little bit to do with the relationship of European Union institutions to the member states, and member states, like, they would prefer like that, maybe not like to be scrutinized in that area as much, and they also, like they said, we just want quite a lot of flexibility there. So what we ended up with is actually still a lot of flexibility and what you could say a directive in disguise. So this is maybe interesting for lawyers, but I think it's an important thing. So then one very interesting, from a technical perspective, addition to the rules is this new concept of pseudonymous data. So it used to be the case that we have, on the one hand, we have personal data. I gave you the definition. So, and then we have data that is not personal data, so any kind of data, but also data that has been effectively made anonymous. But now we have this in-between form of personal data. It is still personal data, but it is data, the processing of personal data in such a manner that the personal data can no longer be attributed to a specific data subject without the use of additional information, and provided that such additional information is kept separately and is subject to technical and organizational measures to ensure that the personal data are not attributed to an identified or an identifiable natural person. So data that has gone through some process of de-identification. And apparently this is really key. You know, I'm hearing that this is very important in practice, and a lot of industry is relying also on this provision because it gives you, it basically gives you a few like bonus cards. You know, it gives you some jokers to say, under this provision, for instance, are you allowed to use data for new purposes? But if you have pseudonymized the data, that gives you a little bit of a benefit there. I think though that this concept itself and how it really works and what it means to do pseudonymization in terms of like offering people privacy guarantees is something that still needs a lot of discussion. So then another element that changed, so there are rules about transparency, and basically you have to say all sorts of things. Usually they're put in a privacy policy. What are you doing with people's personal data? What are you collecting? What are the purposes? Under what conditions? And so this is that you have to be now transparent about the legal ground for processing personal data. And this is very important that it wasn't the case. And so it was always kind of strange, like situation where you had to kind of guess what is the theory under which the controller is processing your personal data. And now they have to be very explicit about that. So there are like notable changes on data subject rights. There's this right to be forgotten, which is like actually called the right to request erasure. So when there's no longer a legal ground for processing, you can request erasure of your data. There's a new data portability right, and just this week there was an announcement of some of the major tech companies working together in an open source platform to allow for this data portability right to work. Quite interesting also technical challenges there. The idea is to like let APIs talk to each other and like allow people to take their data from one service and move it to the next. So it also like relates kind of to competition between services. Then there's a right not to be subject to automated decision making with significant legal effect. That actually was there already, but there's been a lot of discussion, especially in relation to automated decision making, whether we actually now with the GDPR have some right to explanation, and there's some like hint at that, is like that people should get meaningful information about the logic of automated processing. But the real important change, I think, from the PET's perspective, is this introduction of what is called information accountability. This is from an article from 2006 by Danny Weitzner and others, where they said, this is like the headline, it's just a screenshot from the paper, with access control and encryption no longer capable of protecting privacy, laws and systems are needed that hold people accountable for the misuse of personal information, whether public or secret. So this is really giving up on pets in some ways and saying we have to just do this other thing, which is just keeping track of information and being able to tell when something went wrong, whose fault it is and what happened. So the notable changes in the GDPR is that first there is this general responsibility to be able to demonstrate compliance. Then there's the data protection officer, which I just mentioned. So you have to appoint one if you're like public sector or large-scale personal data processing or systematic monitoring, which according to the regulators also includes like internet tracking. Then there's this risk-based approach to compliance and enforcement, and this risk-based approach, you see it most clearly in what is called a data protection impact assessment. And this data protection impact assessment, that is something you have to do in the case that there is a high risk for the rights and freedoms of individuals, and then you have to detail those risks and also detail all the organizational and technical measures that you have taken to mitigate those risks. And so it's like basically you go through some kind of compliance exercise there. And then there's the data protection by design and data protection by default standard. So it's really, you have a general obligation to do data protection by design. So, I mean, that sounds very hopeful. The only thing is that if you look at the provision, the big problem is it's not really clear what it asks you to do. So this is the data protection by design standard. So taking into the account, this is all sorts of considerations, like you have to look at this, you have to look at this, you have to look at this. Like the controller shall, both at the time of the determination of the means of processing and also when you're doing it, you have to implement appropriate technical and organizational measures, such as pseudonymization, so that's kind of singled out, that's something good to do, no? Which are designed to implement data protection principles, such as data minimization, and you have to do that in a way that's effective, and then to integrate necessary safeguards into the processing in order to meet the requirements of this regulation and protect the rights of data subjects. So I mean, like, I'm not able to tell you what exactly this requires, and so there's a lot of questions like, what does it actually mean? I think another important question about this, who is actually responsible for doing this? You know, like, is that like this small scale shop that is a controller, they have to do data protection by design, they're not technical? No, so actually they're like, who are the ones that actually design systems? They're not actually directly regulated. No, the developers are not directly regulated under GDPR, they're often not the controllers. So then there's a recital, so one of those explanations that says like producers, they should be encouraged to take data protection into account and to basically design systems that help the controllers to be compliant with the GDPR. So this is like, just to be very clear, this is quite soft. This is like kind of hopeful that they will do, the developers will do this. So on enforcement and compliance, so it's really like, this is like, the action is really because it's really quite a strengthened regime on enforcement. So we have this information accountability that gives quite a push, but also the data subject rights that we made more explicit, strengthened in certain ways. There are much stronger oversight powers for regulatory authorities, including this possibility that has been widely reported to give really high fines up to a maximum of 4% of global turnover. Now that's enormous for some of the big tech companies, of course. There's this one-stop shop mechanism. Article 29 has been strengthened a little bit into the European Data Protection Board. There's increased coordination between the data protection authorities. There's all sorts of business-to-business activity too. You know, businesses scrutinizing each other on compliance in the processor controller area, but also between controllers. And then there's, and this is one to stress, there's enforcement, not just through these regulators, not just regulators looking at what is the landscape and doing research and going after, like, no, there's a very strong track of pressure, enforcement pressure, coming out of individuals and civil society, using private right of actions, using this data subject rights, asking for what's going on with my data, I want to have access to it, you're not responding in the way that you should be responding. And a lot of this is actually directed at the courts. You know, it's like, so it's like really getting like interpretations that are favorable from a data protection perspective. And then we have this situation where also basically everybody is going to be considered a data controller. You know, so responsibility under the GDPR is really increasingly networked and complex. There's a very broad concept of what is a controller, and this ruling that I mentioned earlier really establishes, like, it's really a sweeping interpretation of what can be considered a controller, but also, like, so this, even in the situation that you do not have access to the personal data, so, and this was in the case, Facebook fan page was considered a controller for the processing of the personal data by Facebook for audience analytics features that were offered to the owner of the fan page. But it's not even that fan page had actual access to those underlying data. But they caused the processing to happen. So, and I think this is a little bit my perspective on this. Is like, it's quite extreme. GDPR has become an instrument of quite unlimited information flow scrutiny. So this is a quote: "Everyone is guilty of something or has something to conceal. All one has to do is to look hard enough to find out what it is. Each organization, permanently aware of its own reliance on personal information architectures, naturally develops a respect for the people who scrutinize these architectures, who oversee compliance with the rules of data protection, that most complicated science, and for these people's authority." Does anybody recognize the quote? This is like, it's actually a famous quote that's used in personal data protection land. It's from Solzhenitsyn, where he says, like, everyone is guilty of something or something to conceal, and then each man, permanently aware of his own invisible threats, naturally develops a respect for the people who manipulate the threats, who manage personnel, records, administration, that most complicated science, and for these people's authority. So I think what the GDPR has done, it's like really given, like, the other side, like this possibility of scrutinizing these systems. And that partly has to do with these very open rules about which you can disagree on their interpretation. So you can go into that system of scrutiny with very strong interpretations of what it means to comply with data protection rules. And you see a lot of that, especially happening from, like, individuals and civil society. So one area where you see this a lot is in the use of data access rights and data subject rights more generally. So they're an increasingly popular instrument. You see that, like, well, so you're allowed to access, request access to your personal data and ask for information about its processing. You see researchers, academics using that, but also journalists are using it, privacy advocates. The interesting thing, of course, is, and the strength is, like, these data access rights, they're basic and they're also fundamental. They're in the fundamental right to the protection of personal data. And they're very powerful as they leverage this broad scope of the concept of personal data. So evidence, when you start using these rights, continues to show very low levels of compliance. So often you're not getting what you're supposed to get. But use of access rights has been shown to be very interesting, and it's also on the basis of the Max Schrems campaigns and reporting on Cambridge Analytica, use of data access rights was very instrumental there as well. So this is another area where there's a current campaign coming out of civil society. There's this new organization called None of Your Business. This is a new privacy organization founded by Max Schrems. It launched a number of cases on GDPR Day, like 25th of May, against major service providers, including Facebook, Google, WhatsApp, and Instagram. The last two, of course, also being owned by Facebook. And one of the key questions there what personal data processing can be considered necessary for the offering of the service. And so he is like doing this litigation on the header of forced consent. So I think this, from a pet's perspective, already very interesting, because you have a service and it's built, let's say, in a quite privacy unfriendly way, and you could say, well, that's not necessary at all to process this personal data or this personal data, because you could have applied this technique and this technique. So it's really that question of like, how far do you need to go with implementing existing technologies that can help you to be less personal data processing intensive. But it's also on this rule of building of personal data processing, the bundling of personal data processing with acceptance of the service. It's not allowed when it's not necessary for the service. So that's a rule that, like I just mentioned. But of course, like, that's kind of circular. It's like that doesn't really answer the question when things are necessary for the service. So, and there you can go in still quite radical different ways. One of them is to say, well, the service provider decides what is necessary for the service by designing the service. You know, that's one option. I think from a US kind of legal perspective, that would definitely be, that's how it works. You know, it's up to the service provider how it works and how it's designed. But you can actually take a completely like opposite kind of radical route that says, well, you have to actually deploy an objective standard of what is necessary, considering the fundamental rights at stake, and then the user should be able to have a choice how personal data intensive the service is that it ends up enjoying. Now, so you have to kind of unbundle the service in a way that, like, there's a version of the service that is not personal data intensive. So this case is likely to move up the legal chain, potentially to the Court of Justice of the EU. So a few coffee cup reading perspectives on pets and the GDPR. How much time do I have left? 4 minutes? I can take a few. So it's hot here, actually. So like I said, there's no clear mandate to implement specific privacy-enhancing technologies. So at least really quite open what particular measures you should be taking. So it's like there's really not much of an answer there. So I think that means that there's a lot of space for showing what you could be doing. No? The pseudonymization part is definitely mentioned. So anybody that like works on pseudonymization, they can be very happy, because like that is something that like will get a lot of interest. So then on this risk-based approach, I think that very clearly invites development and implementation of a specific type of pets that address particular types of risks that are identified in data protection impact assessment. So that's very interesting, no? And not only data privacy risks, but actually quite broadly also other risks to the rights and freedom of individuals. So when you're working on like risks of personal data processing systems, you can include all sorts of risks, including risks of discrimination, for instance. I think there is then, on the implementation, there is a bit of a control paradox, that it's maybe true that the best way to comply with GDPR is to have centralized personal information flow architectures. Because really that gives you this overview, and it gives you the possibility to make yourself accountable for what's happening. It gives you the best way also to respond to people who want access to their data and want you to do things with their data. So that's, I think, a kind of a push towards centralization, apart from the one that you maybe already have, by just the fact that it's really quite cost intensive and hard to comply with. There's no clarity really what is exactly expected, and so there are a lot of inherent tensions and conflicting perspectives in the GDPR. So I think, like what I said, the question is really what the controller wants to do. What is the kind of privacy proposition you want to make towards your users or people affected? But most controllers do not really make these actual data privacy governance decisions, especially not the technical ones. So there you see it's really important to see that it's about this conversation between designers and producers of technical systems and the people that end up really enjoying their functionality, which involves the processing of personal data. And it's that conversation where I think a lot of the action is. So then, like, one thing that I think is important that relates a little bit to the paper, the last paper of the first session, there's really a need, I think, for further development of data privacy technologies that protect people against new forms of data-intensive organizational power. So there is this right against automated decision making, but there you see the protection that policy people really triggered by is like, so you have automated decision making, what is the protection? It's a human in the loop. You know, and I think this is a really, it's kind of a knee-jerk type of reaction of what is the appropriate way to protect people. And I think there's a lot of potential to think about new types of technologies that can be developed to protect people's interests in those contexts. So on compliance, yeah, that I'm very sorry about, but if you take it seriously, compliance can be quite costly. And I think it's especially costly if you do compliance exercises on information systems that have been kind of built from scratch, from the bottom up, in a kind of unique way, doing things with personal data. If you have decentralization in your system and certain forms of encryption, that I think can create a bit of a controllership vacuum. And that is intention of what is expected on the basis of the GDPR in view of information accountability and data subject rights. So you can actually, by implementing certain types of decentralization or encryption technologies, you can lose the control that maybe the legal framework assumes that you should have. And then in combination with the fact that you have this broad concept of controller, I think it's possible that even though you have decentralized things and you do not really have control or access to the data, you suddenly may be considered like a controller, and you cannot ensure compliance with these rights. So you can end up a little bit in a catch-22 situation. So then finally on the enforcement, I think very clearly there's a lot of technical expertise needed in privacy policy and enforcement discussions. There's a big role to play for the community in the detection of data privacy issues in personal data architectures. The documentation of like what are the types of risks of systems and ways to address them. So what I said about the data protection impact assessment, you know, looking at particular types of risks and how they can be addressed, that is a really clear area of work. But on a more conceptual level, giving explanations of what forms of data privacy, particular technologies and organizational measures can help to protect. You know, what are the properties of particular types of measures? Because the space in the law and policy is so open, you know, what is actually being offered if you say you throw a bunch of privacy technology into a system, you know, what does it really help to achieve? You know, that exercise I think is very important, and PETS community input would be very helpful on that. And then finally, research feeding into data protection policy and GDPR enforcement. So being in touch, of course, with regulatory authorities, but also I think increasingly what it would be interesting for researchers to collaborate with civil society organizations that are involved in some of those strategic litigation campaigns. With that, I will finish because I'm a bit over time. Here are my conclusions, but they're just summary. Thank you very much.
In fact, we still have a few minutes for questions.
Hi, so I've been trying to figure this out myself. We see a practice in a lot of data controllers, service providers, where they exclude people using certain privacy enhancing technologies from using those services, whether that be Tor users or whether that be people that have extensions that block trackers and things like that. Do you think the GDPR has anything to say about whether that sort of practice is legal and under what circumstances it might be?
That's a great question. So I don't think that GDPR has no, I don't think they have, they definitely don't have a rule on that, for instance, that you're not allowed to block people. So they have this rule that is looks a little bit like protecting people against this kind of tracking wall type of situation, or like the situation was brought up with apps. But even there, it's very ambivalent. And I think, to be honest, there's just not there's not a lot of support in the law for the use of those more strictly offering confidentiality type of protections to people. That's actually, I think, also why that is a domain where the technical work is so important, to offering the possibility to have these properties, because the law is not really offering them. So the question of whether it's allowed to, I think we would have already seen more litigation if it was really possible to complain about the fact that you're, for instance, not able to use an online service if you're using Tor. You know, it's like, it's not, I don't think there are that many kind of legal, you don't have that much leverage in the law to fight against that. But that's the situation. I think, I mean, to say that the law is hostile against those technologies would go too far. But it's definitely not trying to say, like, yeah, everybody should be allowed to use this. And I mean, it's a bit a similar situation as the way that GDPR relates to obfuscation. When you do obfuscation, of course, like that goes totally against the logic of the system. You know, it's like with obfuscation, you probably end up putting all sorts of wrong personal data in the system, where like this, the idea is actually you're going to make it work. You're going to make all the data that is in the system, you're going to make it correct and give people rights to ask, look at the data is correct. So it's really like a different paradigm of protection.
Thank you for the talk. I had a question in reference to your presentation. Could you shed some light on the recent lawsuit against Facebook and Google by the EU? Sorry, could you shed some light in context of your presentation on the recent lawsuit against Google and Facebook?
On what against Google and Facebook?
The lawsuit
litigation?
against
the
lawsuit against Google and Facebook.
Yeah. So yeah, I mean, I mentioned, like, I put this. I think the lawsuit. This is like, I've been mostly looking at the lawsuit against Facebook on this. So because of this new obligation for controllers to say what is their legal basis, you see now in the privacy policies, you see what legal basis services are relying on, and Facebook, in a, like, I think a little bit risky choice strategically, they really put most of their money on this necessary for the service. So including, I think, the tracking they do with respect to you as a Facebook users on third-party websites and all sorts of things. Like a lot of it is actually bundled and say this is all necessary for what we do, and that includes, of course, necessary because, like, their reasoning is we are offering this stuff for free, and we want to make it very widely available to everybody without having to pay. You know, so that's their reasoning. But I think it's a risky strategy for Facebook. First of all, legally speaking, because it's quite easy to find something that, like, no, that should not be, like, you should not be allowed to bundle that with the acceptance of using the service. But secondly, also because they are obviously the first candidate for being under scrutiny, you know, both by civil society, but also by regulators. You know, so the regulators already created a social media group. I mean, this is like, it's a very clear target in the media. You know, so the scrutiny that they're getting on that is very predictable. And so it's I have a sense that could end up badly for them, that strategy. But of course, then the question is, like, they can still correct it, of course. So there's other litigation also coming out of France, and I mean, this is we will have to see what exactly comes out of that. It's very hard to make specific predictions, but I think with what I said also about the strength of the rulings of the Court of Justice of the EU, it's very likely that quite some of that litigation will have some, like, outcome that will have to lead to adjustment in industries, changing some of the practices.
Yeah, thank you for your talk. So I just want to point out one point. I'm sure you're aware of this, but for the rest of the audience, where there is support for pets in the GDPR, Article 25 talks about taking into account the state of the art. So the question then becomes, from a regulator perspective, is are they going to consider state of the art the academic state of the art and the kind of privacy community state of the art, or the general tech community, which doesn't have access to computer science PhDs who are doing differential privacy and, you know, all of those kinds of things? So which one is the regulator going to accept? The other thing I just wanted to point out, I think you're absolutely right on the two options. You know, when I talk to companies all the time, I always point out that second option, and going back to some work by some people here, Carmela, Claudia, and Seda, on engineering privacy about setting a goal and then looking what is to reach that kind of high-level goal, what is the minimal amount of data that you can reach that high-level goal. Because I go into companies all the time and they're like, oh, we're trying to do this, and then I start digging deeper and no, we're really trying to build a surveillance system, you know, and end up, and we really want to collect a whole bunch of data. We're not trying to do something that's privacy preserving. So I think that's a very critical point.
Great, thanks.
I was wondering how the GDPR looks at technologies like multi-party computation or homomorphic encryption, where basically organizations can say we don't have the data, and therefore we don't need to be compliant with GDPR.
Yeah, so that goes like this is something that has struck me a lot in like looking at some of the technological measures that are taking in industry context also, where like one thing I looked at is like Facebook, they're partnering up with this data broker that has like all this information about sales in stores and brick and mortar stores, no, like real world stores. And so they partner up with this data broker and they implement some kind of privacy technology scheme, you know, that allows them to then measure, you know, like how advertising at the individual level on Facebook are driving sales at the individual level in stores. So this partnering up like allows them to do this kind of measurement, which like that would be exactly the kind of thing you want to achieve if you combine the data sets. But then they're saying we're not going to exchange any PI, no, like PII. We're not going to exchange any personal data. So that is, I think, the question is it GDPR, is this really about preventing personal data from flowing, or is regulating personal data processing a proxy for trying to achieve something else, for trying to achieve conditions of privacy? I think it's the second thing, you know, and this personal data is just a proxy to regulate something or to protect, to give certain safeguards. But if you have this narrow idea of like it's actually about personal data processing and try to prevent that, you can forget that you end up like implementing technologies that are doing something for privacy. They are doing something, but it's actually quite limited, you know, and it's actually not protect against the thing that is actually combining the informational power that is in these separate databases, and also would like it's like achieving exactly nothing in terms of like the combination of that or data-driven power. And I think that is somewhat worrying. Now, it's also somewhat worrying that it allows you to really, like the GDPR allows you to say we are doing all this great stuff. You know, we have this very advanced like privacy technologies, you know, implemented in all sorts of like local parts of the information system and all sorts of interfaces that we have, you know, but not like require organizations to have like the bigger picture kind of answer about what is actually this proposition towards individuals in terms of their rights and freedoms. Thanks.
Yeah, so I mean, I think what my question has always been, what really is the protecting human rights around privacy and data protection. And but in execution, I feel like the GDPR actually is mostly about restricting commercial transborder data flows. And the reason is because the GDPR has a giant loophole in it, which you did note briefly, which it does not apply due to national security exception derogations to nation-state level intelligence agencies and law enforcement. So to my knowledge, I'm running 2 court cases on this, is that effectively, if you do believe that you have some personal data held in a public body, particularly an intelligence agency, you have essentially no data protection rights, no right to correction, no right to be forgotten, and that's, I think, actually really dangerous. And if you look at it, that's why, for example, even though you had data protection regulations in the UK, 2011 and 13, effectively, when the NSA had to do some dirty work, ask GCHQ to, because again, all these wonderful laws only apply to commercial. And that's, I think, a very dangerous presumption then. It's very dangerous to assume that this actually defends human rights. And when you say, well, if only, then it actually, the GDPR seems to look more and more like essentially a Europe to do some fining of Facebook and some essentially trade protections, which I'm okay with as well, but that doesn't have too much to do with actual real-world privacy or human rights. Now, the only thing you mentioned, which I would love some more explanation on, is apparently the police data protection regulations, which I have not seen very much, if nothing, on, and are not currently enforced, even if they ever will be.
Yeah, so like just to quickly start on the last one, which is probably easiest to answer. So you have specific frameworks, regulatory frameworks in the member states for what police are allowed to do with personal data. Once they have collected, are they allowed to share it, what they're allowed to do with it. So this police data directive is a directive that harmonizes this across Europe. There's still a lot of flexibility in it, but it's kind of like it just says this is for all police, law enforcement, personal data processing in Europe. And then on that basis, it also sets the conditions for law enforcement to share personal data between different national law enforcement agencies. Because if you have different laws, then it's going to be like, are you allowed to share it? And they're going to like the Germans are allowed to do so much more with the data, so then the Dutch, they're not willing to share it. You're going to end up in this situation. So it's a harmonization exercise. On intelligence, I mentioned also the international standard, the Council of Europe Convention, and also Article 8 of the European Convention of Human Rights is also applicable to government data processing in the intelligence context. So that's an important final safeguard, and you see quite some of the litigation also after the Snowden revelations, and also in the UK, the Big Brother Watch and Privacy International and other case about national security surveillance. That is happening within the boundary of Article 8, and a lot of like case law about like what is allowed with national security surveillance. So there is still some law there, but it's true that in many ways, and I think it's a very similar situation. It's like we have this research about like what is happening on Facebook, and Facebook giving all sorts of controls and policies that give people the idea that they have control over their personal data, and that like incentivizes people to share more, and so of course the GDPR is also there, and one of its explicit goals is actually to give people trust in an information society where personal data is flowing very freely and pervasively. That is one of the goals of the law. It's actually, so in many ways it normalizes the situation where our personal data is flowing all over the place and being used to power services, to power all sorts of functionality and organizational practices. And I think you were hinting at that in some other ways, and that's completely right.
So I wanted to have your opinion, but it seems that the notion of pseudonymous data is quite dangerous because pseudonymization is very weak in terms of privacy guarantee, and a lot of companies might be tempted to just go for that and instead of doing more. So I wonder what you think about the introduction of this concept.
Yeah, so I think, I think you're right. So the point was like, what do you think about the pseudonymization? This is actually, from a privacy perspective, it's quite a weak measure. And is this not then just very easy, like you just do a bunch of pseudonymization and then you're complying with the law already? And I think, that's true. I think that is a problem. The situation in the debates, like in the legal debate, like the political debates about what the law should be, there was really a design for a GDPR that had GDPR light for pseudonymous data. You basically, you could, like, you didn't really need like much of a legal basis anymore. You had much less transparency obligations. There was really a light regime for pseudonymous data set up, but it didn't make it into the actual final text. The final text is very clear that it helps you to achieve compliance, but it doesn't change the rules that apply to you. So in some ways, the situation is much better than it could have been, and I think that was really what was pushed for. The struggle, like I'm really struggling with this also from, let's say, more a conceptual perspective, what it really means to pseudonymous data and why is that really a meaningful thing to do. You know, because it's really about this thing of de-identification, and like the identifiers we have in our society, they're quite contingent on like particular kind of information architectures. A lot of them are quite outdated, you know, like so on policymakers, it's like, what are identifiers? You know, they're going to be like, well, that's a name, and it's like maybe your address of your house, you know, or like a telephone number. But there are so many other identifiers or combinations of information that are actually identifiers. And so it's not exactly clear, like, what is your starting point of that exercise of pseudonymization and like the identification of data. You know, so this is something I'm actually struggling with. What is actually happening there? You know, what are you actually trying to achieve, especially in a digital environment where we have so many new forms of identifiers and we have so many ways in which information systems can play with these things. So, I mean, you're probably better able to answer the question of how sensible it is to do something of pseudonymization, also in respect to a particular system and a particular. But I think that's what's needed. That's what it's really needed to explain what are you actually achieving here and what are you achieving for people.
So 2 questions. The first one, is it possible that we'll have a paradoxical result that small data controllers will say, I'm not privacy preserving, privacy protection because I'm screwed anyway. It's impossible for a small organization to do it right, so why bother? So that's the first question, is whether they'll just ignore everything on the assumption that you can't get it right anyway. And then the second question is, again, predict, please, 5 to 10 years from now, how are we going to look at GDPR? What's the impact going to be? Are we going to say it's a success or a failure? And how will it change things? Thank you.
Okay, great question. So the first question is, what to think about the possibility that small data controllers, you know, maybe not have the knowledge and capacity. They're just like really like, I'm not going to do this at all. You know, so like we have to look at it from, I think, from the starting point situation is that nobody was doing much at all. No? So there was not much compliance with the Data Protection Directive. You know, and the GDPR creates a situation where there's much more compliance. So, I mean, I would say the glass is half full there still. You know, it still achieves something, and it also achieves something, especially with respect to the entities that do the most and have the most kind of, like the most influence in privacy governance land. No? So, and I think, yeah, I mean, and I don't think I'm not so interested in those much smaller organizations. I think the problem, of course, is they could be targeted in ways that are not fair. You know, like it could be that regulators suddenly go after a particular sector, or like in ways that are problematic, or it could be you can use it against your competitors. You know, you launch a data subject access campaign against one of your competitors. You know, but you can do things with it that are potentially problematic. So that's really that's then at the level of enforcement, you know, and finding also, I think then the second question is like how to evaluate whether the GDPR did something right, you know, let's say in 5 or 10 years. And I think that is very, very difficult question that I'm trying to set up like some work on. Is like, what are actually the right standards to evaluate this? You know, because this is such a broad, sweeping framework, which also has such quite a vague norm, you know, and so like, of course, you can look at it in terms of compliance, you know, and you can start like tracking that, but really for evaluating whether it does a good job, and also on the more specific question of the resources that are put into both organizing for compliance and then also evaluating that, it's like, are they well spent? That is a very, very difficult question, because you can go so many different ways, you know, and it's very easy to, I think, to see like my intuition, there's going to be a lot of paperwork, there's going to be a lot of box ticking, you know, like, and it's not going to be that meaningful, you know. So the question of how meaningful the things that the GDPR is going to achieve they are hard questions. So We need to find ways to evaluate that and prepare for that evaluation. That allows us also then to say this needs to be tweaked and this needs to be improved and this needs to be changed a bit. Yeah.
Yeah, so just to add to this comment on pseudonymization, because earlier you talked about sensitive data, and you said that sensitive data means data that can reveal some sensitive attributes, but is this defined in the GDPR what sensitive attributes or that sensitive term really means?
So, sorry,
What
is
does
the
it mean for
question
data to be
whether
sensitive?
it's defined? Yeah,
or
so it's
any,
defined in the GDPR defines those particular attributes. So ethnicity, race, sexual orientation, religious beliefs, they're put in there. So that's clarified. But the question of what information reveals that and like what is the standard, it's really messed up. I just have a master's student finishing with a thesis. She just sent it to me, and like she looked into the standards, and it's an utter mess. And you see like all the regulators like moving around with their interpretations of what it really means for things to be sensitive data. Like, and one of the reasons they had to do that is because of our visual culture and everything being pictures. And if you like have pictures, you know, like they reveal a lot of those things potentially also, because it's one thing to say with 100% certainty you can tell for the data from the data that, you know, this is the case, but that is of course not the right standard, especially when like a lot of data systems are about making certain types of predictions with a certain amount of certainty. No, so I mean your location data is probably is health data. You know, like your pictures are this, so then you see the regulators kind of moving their interpretations around, and they say, well, like if it's not, like if you don't really have an intent to know what these sensitive attributes are from like by processing it, you know, then you're not under those rules. You know, but it's like but then in other situations they're very strict. They say, well, this could even be potentially revealing of this, and then so that's how the regulators, and then you have court cases at the lower level and at the higher level making a very mixed picture. And this is something that it actually was known already in the 70s that this was probably a much too simple way to think about this problem of sensitiveness, you know, in personal data land. And now it's still in the GDPR. There's a court case in the right to be forgotten context. Google was confronted with requests that have to do with removal of data about criminal convictions. And this is one form also of sensitive data. And so the Court of Justice, they have to make a ruling on what is the scope of that and how much of an exception is possible with those rules on sensitive data. So there's, and there will probably be a lot more to come on that.
So, about the role of the processor in the context of the web. So this is a very complex and dynamic given website. Can you hear me?
No, you're switching off sometimes, but I think the other microphone seems to be working quite well.
Maybe some radio issues. Yeah.
Can you, maybe the other?
So yeah, I was asking that I'm curious about the role of the processor in the context of the web, because this is a very complex and dynamic ecosystem in which you have multiple players. Like, for instance, a given website may have a given ad network, and that network may actually leak data or share data with another service because of all the ad mediation ecosystem. So how can this specific website actually list all those processors of data that are actually going to show up in a very dynamic way? How does actually the GDPR try to prevent or control that kind of personal data dissemination?
So you're talking about the situation in which, let's say, a website has integrated a bunch of like tracker functionality and things like advertising networks, and is that the situation that you're trying to?
Yeah, it's like, for instance, your website has DoubleClick.
Yeah.
And then DoubleClick dynamically loads some content from another partner player, like for instance Criteo, right? Which is something that is a consequence of the ad mediation and the bidding happening in the web. So how does actually the website need to know that Criteo will actually collect some personal from the user?
Yeah. Well, I mean, I'm not going to answer, like, I'm not going to give the legal answer to this very specific situations because it's quite hard, but I'm going to say a few more general things about it. So first, there's a case there is about integration of Facebook like buttons on, the Court of Justice has to decide that pretty soon. It's a bit similar case as the Wirtschaftszimmer case that I described, and it's really about the question, in what situations are you a controller? So if you integrate third-party type of personal data processing things, or you just put a pixel, but it leads to personal data processing, the question, of course, is, as the original website, what is your responsibility for what those other entities are doing with personal data? You know, and there you could say, well, they just have their own responsibility. But what you see happening now is that also the first party is made responsible for what the third parties are doing with their personal data. So they already have to negotiate then on whether that's legal or not. So this is something you see it also, you saw this dynamic played out openly in legal discussions between the publishers and Google, where the publishers were asked to ask for consent for what Google is doing, you know, and the functionality Google is offering them. So you can see a little bit of like GDPR debate on that. But I think the problem is really that it's not that clear who is a controller and who is a processor. You know, like you can easily also move out of the processor concept if you start doing things with the data yourself. You know, and which is often, of course, the case. It's like maybe you're offering some functionality, but then by wanting to improve that functionality, and you want to use the data that you have from all the different customers that are using your functionality. You want to learn from that and improve, and then you become a controller as well. You know, and then and it's like the situation, technically speaking, is so complex and networked. That the data protection is quite struggling with finding the right ways of attributing the responsibility, let alone apply the rules. So this is it's really at the basic level, you know, of like who is even responsible, that we have very, very hard questions that we're still grappling with. You know, like that's why I said also there's still quite a lot of legal uncertainty, you know, about these situations. So, I mean, it's just like, then in the end, the question is like, of course, like you can make some kind of agreement between those entities. This is going to be your responsibility. This is going to be mine. So that's something you saw between Google and the publishers. And that's like then the question is, can that withstand scrutiny? You know, and like like you can imagine that it can, but like to make that kind of initial determination is quite a lot of work, and it requires a lot of coordination that maybe doesn't even exist. No, so it's complicated.
Okay, it is always a pleasure to have scholars from communities that are related to privacy but are not technical speaking to us. Actually, as punishment, we actually will make our speakers sign a consent form to use the video, which is relating to data protection. But I would like to thank Joris again for a very interesting introduction and all the thoughts.
Thanks everyone. We went over time a lot. Yeah, sorry.
If you would like your English to be available